Hey guys, here we have a grade 12 June Maths Paper 1 exam. If you want to download the paper, check the description below. Then you can download the paper and see what questions are coming up. 150 marks, 3 hours. Let's do it. Okay, so here we just have two solve for X kind of questions. So this first one over here, you see it's only for 3 marks. And it doesn't say correct to 2 decimal places the same way that this one does. So this one would usually just be a basic, factorize. So if you have x squared take away 7x plus 12 equals to 0. I know that 4 times 3 gives me 12, and 4 and 3 also makes 7. So we could say 2 brackets, and we could say x, and then take away 4, take away 3, because minus 4 minus 3 does give me minus 7. Alright, and then what we can do is we can then say that x minus 4 must be equal to 0, or x minus 3 would be equal to 0. So therefore, x is 4, or x is 3. Okay, so x is 4, or x is 3. This next one says correct to 2 decimal places. That tells us that we're not going to be able to factorize. We're going to have to use the quadratic formula. So the first thing I would do here is just multiply the x into this bracket. So that would give us 3x squared plus 5x equals 1. Now, to be able to use the quadratic formula, we need to bring this 1 over. So we're going to have 3x squared plus 5x take away 1 equals to 0. Now, the quadratic formula is x equals to negative b plus or minus the square root of b squared take away 4ac over 2a. So in the test, you would just write that over here, for example. Now you would go substitute in. So remember that this is your a, this is your b, and then this would be your c. So that's going to give us negative 5 plus or minus the square root of 5 squared take away 4. Now a is 3 and c is negative 1 over 2 multiplied with 3. Okay, so now I'm going to go type all of that in on the calculator. For the first one, I'm just going to use a plus, and then for the second one, I'm going to change it to a minus. And the two answers that we would get would be negative 1.85 or x would be 0.18. Oh, I actually got the 0.18 first. Doesn't really matter. So those would be your two answers. With this question, we have a quadratic because we have that, and it's an inequality. So you need to get everything to the one side. So I'm just going to bring the 2x and the 15 over, and then this side will just have a 0. Now, what you do here is you are now going to you need to go get something called your critical values. Your teacher might or might not call it that. But to get your critical values, you are going to make the equation equal to 0, and you're going to go solve that normally. So this one can be factorized, but you could use the quadratic formula if you wanted to. But it's going to be x plus 5 and then x take away 3. And so that would mean that x plus 5 is equal to 0, or x take away 3 is equal to 0. So x is then negative 5, or x is equal to 3. Now, those are not your answers, and I also don't want you to say, oh, okay, so it just means that x is smaller than minus 5. This part here is wrong. Or x is smaller than minus 3. Or, sorry, 3. You don't want to do that. What you're now going to go and do is these are just your critical values. So you're going to draw like a number line. So you're just going to draw a line. And you're going to put those two numbers in the correct order. So minus 5 is first because it's smaller than 3. Now, there's multiple ways you can do this, but one of the ways I like to do it is I look at this and I realize that what type of graph is that? Is it a straight line, parabola, hyperbola, exponential? It's a parabola. Is it a happy parabola, one that looks like this and it's got a smiley face? Or is it a sad parabola with a sad face? Well, the way that you work that out is you look at this value here. It's a 1. It's positive. So it's happy. Positive people are happy. Think of it like that. So that I hope you to remember. So you go like this and like that. Okay? So that's what the parabola would look like. Now, they are asking you here, where is this parabola? Where is that parabola smaller than 0? What that part there means, smaller than 0, is, let's just write here, smaller than 0 means below the x. So this is your x-axis. So where is the graph below? Can you see that it's here? It's that part there. So that is from -5 up to 3. So if you use interval notation, you would say x is an element going from -5 up to 3. I'm not including the values because they never, it looks like, it made it look like there was a little line there. There's no line there. You can see that they never included it. If you prefer set border notation, you could say that x is bigger than -5 but smaller than 3. Here we have a square root equation. So all you do is you need to get the square root by itself. But here we can see the square root already is by itself. But if the question rather did something like this, where, for example, this one was over here, then you would see that this square root is not by itself. And so what you would do first is you would take this over to the other side. But what we have is a question where they've made it easy for us, where the square root is already by itself on the left, and then everything else is on the other side. So what you do is you square both sides. Because in maths, if you do it on the one side, you must just do it on the other side, like that. Now, this too is a square, and that is the opposite of a square root. So it cancels the square root out. So in the next step, all that you would be left with is whatever was in the square root. And then on this side on the right, I'm going to make 2 brackets. Don't just say x squared and 1 squared. A lot of learners still do that. Rather do 2 brackets. And then you're going to multiply and simplify, so it's going to become 2 minus 2x. And then on this side, I'm going to end up with x squared, take away 1x plus 1. Now I'm at a very easy situation where I just want to simplify. I want to make a quadratic equation, so I need to make a 0, either on the left or right. It doesn't matter. Because I see that most of the things are on the right-hand side here, I'm going to take these two and bring them over to the right. But of course, if you rather wanted to take everything to the left, some learners are just so used to doing it that way that they feel uncomfortable doing it another way. That's also fine. But I'm going to just take everything to the right-hand side. So minus 1x plus 1 minus 2 plus 2x. You see I took those two things over, so their signs changed. Now, I'm just going to simplify. So here we have minus 1x plus 2x. So those all cancel out. Now, a lot of learners, when things cancel out, they think, oh, so I must just say x. No, if it cancels out, you don't put anything. Because as soon as you put x, that actually means 1x. But we don't have any. Now, what is 1 take away 2? Well, that's negative 1. Now, this next part you can solve in 2 different ways. You could use difference of squares, or I think what most of you like to do is let's take the minus 1 over, and then you take the square root. But when you take the square root of something like this, you must say plus or minus. So I'm going to put the square root on both sides, but I'm going to say plus minus here. So that means that x will be equal to plus or minus 1. And so what we must always remember to do with these questions that have a square root is to check. So let's just quickly check that which ones work, which ones don't work. Okay, so if x is equal to 1, then let's see what this left-hand side would equal. So let's see what the left-hand side will be. So that'll become square root 2 times 1 minus 1, and that'll equal 0. Then if you check the right-hand side, which is this side, if you plug in 1, you're going to get 1 and then minus 1, and that's also 0. So therefore, left-hand side is right-hand side. So that solution is perfect. Yes, that's a good one. Now, let's check the other side. If x is minus 1, because that's this one over here, then if we plug it on the left-hand side, then you get square root of 2 times 1 minus, and then x is minus 1. And so that's going to end up becoming 2 times 2, which is the square root of 4, which is 2. Okay. Now, what is the right-hand side? that'll be x as minus 1, which is minus 2. So here you've got the left-hand side and the right-hand side not being equal to each other. And so therefore this one is not applicable, so NA. And so therefore your only answer is x equals 1. Solve for x and y simultaneously. So what I think we can do is we can break this number to 3 to the power of 3. Because now we know from exponential equations that when these two are the same, you can ignore the base. So now we have x plus y equals 3. Now that looks like a beautiful equation that we can now use simultaneously with this one. So we can call this equation number 3, we could call this equation number 1, we could call this equation number 2. Let's go get x alone. You could get y alone, doesn't really matter. And I'll call that equation number 4. Now we're going to sub equation 4 into equation number 2. Okay, so you see how we have x, and so we're just going to go plug it in by the x. So we're going to plug it in as 3 minus y. So I'm going to say 3 minus y squared. Then that 2 is over there. And then I'm going to say plus y squared equals 17. And then now we have an equation that just has y. So don't take this 2 and just put it there and put it there. Remember, make double brackets. It catches a lot of you out. 3 minus y plus y squared equals 17. And so that's going to give 9, take away 3y, take away 3y, plus y squared equals 17. Now I'm just going to bring everything over to the one side. Simplify a little bit, so this y squared plus this y squared becomes 2y squared, and then this take away 3y becomes negative 6y. Some of you might be like, why is it not becoming a positive? Because we're not multiplying. I know the whole negative and a negative makes a positive, but that's only when you're multiplying. And then this 9, I'm going to say plus 9, and then I'm going to bring this over to become negative 17. And then if I put these two together, negative 8. So I'm just going to erase that to save space, and we have that. Okay. Now, you can divide all of... you can go straight to the quadratic formula over here if you want to. You can divide everything by 2, which is what I feel like doing. So I'm going to divide everything by 2, and so that becomes y squared, take away 3y, take away 4. Now, you could still use the quadratic formula right now. You could also factorize. This one actually factorizes very nicely into y take away 4 and y add 1. And so if you had to go and solve this eventually, you should get that y equals 4 or y equals negative 1. Now we can go get x. So I'm going to start with y equals to 4. So if y equals to 4, then I'm going to come back to this equation now. Then x will be 3 take away 4, which is negative 1. And then if y is equal to minus 1, then x would be 3 take away negative 1, which ends up becoming 3 plus 1, which is 4. And so therefore the final answers will be that x is equal to minus 1, x is equal to 4, y is equal to minus 1, and y is equal to 4. This is the kind of question that could make you feel pretty panicky when you see it in an exam. Now, this is a typical question 1.3. They usually are very weird. Now, remember, it is only 3 marks, okay? So if you're a student that gets in the 40s, 50s, 60s, even 70s, look, you don't have to do this question. If you're a student that wants to get 100%, or if you're in the 90s, well then obviously you'll be a bit more comfortable and you should probably do this one. But I don't want the learners that are getting like 40s, 50s, 60s, whatever. I don't want you to waste a lot of time in the exam with this one, okay? It's only worth 3 marks. So it should not be more than about, let me just work this out for us quickly. You shouldn't take more than about 4 minutes to waste on this one. Okay, so there's not much you can do here besides realizing that you've got square roots in the denominator. And we've learned that when you have square roots in the denominator, we can do something called rationalize the denominator. So I'm going to take the first one, okay? Now, how would I rationalize that? Well, all you do is you multiply the top and the bottom by the reciprocal of this. So the reciprocal just means put the opposite sign in between, okay? And let's see what that becomes. So at the top, you're just going to multiply. So that just becomes square root 1 minus square root 2. At the bottom, you are going to multiply as if you were multiplying two brackets. So you're going to say square root 1 times square root 1. That just becomes, it just becomes the square root of 1, which I'll help you with that now. And then square root 1 multiplied by the negative square root 2 just becomes negative square root 2. The way that square roots work is that if you have square root 3 multiplied by square root 5, then you just make it square root 15. They can multiply like that. Okay, now I'm going to multiply these two together. So that's going to become 2 times 1, which is just 2. And then I'm going to multiply these two together, which will just become negative square root 4. Now, if I had to go and work this all out, at the top, I've got square root 1. What is the square root of 1? It's just 1. So we're going to end up with 1 take away square root 2. At the bottom, these two are going to cancel. And then this is just going to be 1. And this is just going to be 2. Because the square root of 4 is 2. So we're going to end up with 1 take away 2. And so this all just simplifies to 1 minus the square root of 2 over negative 1. Okay? Now, let's go see what happens to this one over here. Or let's actually leave it as 1 minus 2. I just want to see something. I think there's going to be a pattern that we're going to observe. So let's try this one now. So now we're going to get 1 over the square root of 2 plus square root 3. And now we're going to rationalize that. So you're going to just do this. And I'm going to actually leave this as a square root, because there's patterns that are going to emerge, I think. So if you had to multiply the top, you're just going to get square root 2 take away square root 3. Now at the bottom, you're going to multiply as if you were multiplying brackets. So you're going to end up with square root 2 times square root 2, which is square root 4. Then you're going to say square root 2 times square root 3. But now, to save us time, this is going to give you negative square root 6. This is going to give you positive square root 6. So that part would have cancelled. And then you're going to multiply these two, which would give you negative square root 9. And so if you had to simplify, you can't really do anything at the top. But at the bottom, you end up with 2 take away 3. Okay, so what I notice is that the bottom of this one was minus 1, and the bottom of this one is minus 1. So I'm going to change both of those to minus 1, because it looks like that's probably going to be a constant. So we now have the answer for this one, and we have the answer for this one. Let's do one more. Okay, it's definitely going to be longer than 5 minutes or 4 minutes. But yeah, it's okay. It's quite a weird question. Okay, so what I've done is I've just written the answer for this one over here, and the answer for this one over here. Now we're just going to do one more just to make sure about the pattern. And so that's going to be 1 over the square root of 3 plus the square root of 4. So we're going to multiply the top and bottom with the reciprocal again. Okay, now we know that the square root of 4 is 2, but let's just leave it for now because we want to see patterns. So I'm going to multiply the top and the top. That's just going to give us square root 3 take away square root 4. And then the bottom is just going to become, so you're going to multiply these two together, which will become square root 9. Then if you had to multiply those two together, it'll be negative square root 12, and then this would be positive square root 12, so they would cancel again, and then we would multiply these two together, and that would become negative square root 16. And so that would end up becoming square root 3 take away square root 4. At the bottom, you would have 3 minus 4, because that's 3 and that's 4. And so once again, at the bottom, you're just going to have minus 1. Okay, so, right, so that's what you have there. Now, they want us to plus all of these things together. Now look at what's going to happen. We know that when you plus things together, if the denominators are the same, then that's great. You don't want to cancel the denominator. We don't have an equation. But if you have like 1 over 5 plus 2 over 5, then you can plus them and it just becomes 3 over 5. So because all of these denominators are the same, that's great. We can add them all together. And remember that it's going to go all the way to plus 1 over 99 plus the square root of 100. And without even doing any calculations, we can work out what this one would be. Because have a look at all of them. Can you see that the 1 and the 2, the square root of 1 and 2, they go to the top and the plus changes to a minus. Then you have a square root 2 and a square root 3. They just go to the top and it changes to a minus. Here we have a square root 3 and a square root 4. They just go to the top and it changes to a minus. So here, you're just going to get the square root of 99 and the square root of 100, where it'll change to a minus, and then you'll just say minus 1. Now here's where the magic happens. So we're going to add all of these together now. And you're going to say square root 1 minus square root 2 plus square root 2, take away square root 3, plus square root 3, take away square root 4. And it would just keep going on and on and on and on and on. And eventually, you see how these two are always the same. 2 and 2, 3 and 3, 4 and 4. So this next one would have been plus square root 4, take away square root 5. Then it would have been plus square root 5, take away square root 6. Then it would have been plus square root 6, take away square root 7. And so what we can see is that these are going to cancel because the ones are plus and the ones are minus. These are going to cancel. These are going to cancel. These are going to cancel. They're all going to cancel. At the end, you would have probably eventually had plus square root 98 minus square root 99 plus square root 99 minus square root 100. So the 98 would have cancelled with the previous 98, the 99s would have cancelled, and you would have been left with that. So all that you would actually have been left with is this one over here. No one cancelled with that one, and no one cancelled with this one. And at the bottom, you just have that. Now, the square root of 1 is just 1, and the square root of 100 is 10. And so you end up with negative 9 over negative 1, which is just 9. They tell us that we have a geometric series. Okay, so remember what geometric means. It means that they are multiplying by the same number each time. Now, it says the first question, is this a convergent geometric series? Justify your answer with necessary calculations. Okay, so if I, for example, give you a geometric series like 100, 200, 400, 800, well, let's make it a series, so we put pluses in between, hey? So plus, 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 and it goes on and on and on. Is this geometric? Well, yes. You can see that I'm multiplying by 2 each time. So because I'm multiplying by a certain number, we call that geometric. But how do we know if it is convergent? Well, if I keep going with this sequence, is it eventually going to stop growing, or are the numbers just going to become larger and larger and larger? Well done if you realize they're just going to become larger and larger and larger. It's going to go 1,600, 3,200, 6,400. These numbers are just going to get larger. That means it is not convergent, okay? So the R value was 2. Now, what if I gave you something like 1,000, 500, 250, 125? What is half of that? 62.5. And then it just gets smaller. Can you see that these numbers, if you had to just keep going and you keep going and you keep going, these numbers are eventually going to become very, 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 very small. Eventually, the numbers become so small that the calculator will eventually actually just say 0. Some learners ask me, they're like, yeah, but Kevin, won't the numbers just start becoming negative? No, try it for yourself. If you're sitting there at home right now and you can see here that every time we're going from one number to the next, what are we multiplying with? We're multiplying with a half. Some people might say we're dividing by 2, which is correct, but in geometric sequences, we don't look at what we dividing with, we rather look at what are we multiplying with. So we're multiplying by a half. Now, if you had to go type this number on your calculator, and then just keep saying times a half, times a half, times a half, times a half, and you just keep going, eventually you're going to get to 0. The number won't start becoming negative. It cannot do that. It just gets to 0. So then, imagine this. Imagine we actually didn't have semicolons here. Imagine we had pluses, plus, 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 plus. Eventually, you're going to be plussing all of these numbers together, and eventually you will be plussing 0, and the next number would be 0, and the next number would be 0. So if you keep plussing 0, can we agree that the sum of all of these numbers will eventually stop growing? Because eventually you are going to be plussing 0, and if you keep plussing 0, your sum is not going to change. We call that converge. You can think of it as The series has stopped. Okay, so how does a series converge? Well, here we had r as 2. Here we had it as a half. There is actually a rule that says if r is any number between 1 and -1, then it will be convergent. Okay, if I show you that on a number line, if this is -1 and this is 1 and this is 0, if r can be anything between those, then it will be convergent. That is for r. How do we calculate r? R is this number over here, or this number over here. That is r. Okay, so it says, is this a convergent, or is it a convergent geometric series? So we're going to go work out the value of r. How do we do that? Sometimes it's not very easy to see. So what we do is we say term 2 divided by term 1. And so that'll give us 1 over 15 divided by 1 over 5. And if you calculate that, you end up with 1 over 3. Now 1 over 3 is like 0.33, which is between -1 and 1. So that means that it will converge. So we will say, for this question, you would have showed all of this over here, and you would say, therefore, it is a convergent geometric series. This next question says, calculate the sum to infinity. Very easy. There's a formula for that. Sum to infinity equals to a over 1 minus r. And so a is term 1, which is 1 over 5. R, we've just calculated as 1 over 3. Go ahead, type that in, and that'll give you 3 over 10. An arithmetic and geometric sequence are combined to form a pattern. Right. So when they say that an arithmetic and a geometric are combined, it usually means that one term is arithmetic and then the next one is geometric, or the first one's geometric and then the next one's arithmetic, and then it keeps changing like that. Now, I can already see that this term and this term and this term, they are the geometric. How do I see that? Well, I know that to go from here to here, you have to multiply by 1 over 3. And to go from here to here, you have to also multiply by 1 over 3. If you didn't see that, you can also say this term divide this term, and you'll get 1 over 3. And then if you say this term divide this term, you would also get 1 over 3. So this, and this, that's the geometric. The one with R. So that's going to be, actually let's do this. Do that. And then the other ones, that would have to be the arithmetic. And we can also show that those x's are going to be arithmetic. Of course, we don't know what x is, but even if you had to look at what is this term minus this term, remember with arithmetic, we're not going to say divide, you're going to say minus. You know when you say like t2 minus t1 for arithmetic, and then with geometric, we usually do t2 over t1. Because in geometric, we look at the ratio, whereas in arithmetic, we look at the difference. So even if you had to say 2x minus x, that'll just give you 1x. And if you then had to take this one minus this one, 2x, 3x minus 2x, that'll also give you 1x. You see how the difference remains the same? So yeah, it's definitely arithmetic. So the first question says, write down the next two terms. Okay, so it's going to be this one that comes next. So there would be 4x. So that would be 4x. I'll write it over here as well. Then the next one would be this pattern. So you would just multiply that by 1 over 3, and that would give you 1 over 81. So those would be the next two terms. This question says, determine the general term Tn for the odd terms. Now this is where I've had questions about this in the past. A few months ago I had a learner ask me about this paper, and I hadn't recorded the paper, obviously. I'm only recording this paper now. But they were getting very confused with odd terms. They were looking for all the odd numbers. But no, they said the odd terms. So remember, this is term 1. This is term 2. This is term 3, this is term 4, That's term 5, on and on and on. So the odd ones, they're not talking about odd over here, they're talking about odd over here, the odd terms. So that would be term 1, term 3, term 5. So they're talking about the arithmetic pattern, actually. Well, why didn't you guys just say arithmetic pattern over here? Whoever set the paper. No, I'm joking. Obviously, they like to challenge us a little bit, hey? So, because our lives aren't stressful enough as they are. So, we have to be challenged. So, it says, determine the general term for the odd terms. So, it's pretty much just going to be the arithmetic pattern. Write down your answer in terms of x. Okay, so we know that if it's arithmetic, then we use this formula for Tn. And so let's just get rid of all this now. So remember, we're not looking at this and this and this right now. So term 1 in this pattern is going to be x. The number of terms we don't know, we leave that as an unknown. And then what was the common difference? Well, I showed it to you over here. It's just x. You can say 1x or x, it doesn't matter. And then, I mean, technically that would be correct, but it's usually better to go simplify. So the way that you would simplify this is you would multiply this x into the bracket. So it would become xn minus x. Oh, that's lovely, because then these two x's are going to cancel. And so the answer is just going to be xn. Wonderful. Okay, type of answer that'll give you a heart attack in a test. It's like, what? I've never seen something like this before. Am I doing it right? Oh no, my life's a lie. That's the thought you would have in the exam if that had to happen. Well, at least when I was a student, probably. xn. All right, there we go. This question, this is quite a good one. It says calculate the value of p26. So this is the p sequence. So let's just get rid of this now. So now it means that everything is included. So now you got to think carefully. Where would 26 be? Would 26 be a part of the arithmetic pattern? Or would it be a part of the geometric pattern? Well, remember that the arithmetic is term 1, term 3, term 5. So it's all the odd terms. 26 is an even number. So it's going to be part of the geometric. So we're going to use the geometric formula. But now be careful. We're not going to go find term 26 now. Because what you must imagine is that we take the geometric sequence out of this thing. So now we just have 1 over 3, 1 over 9, 1 over 27. So if it's term number 26 inside this pattern, what term number would it be if we break it out into its own one? Wouldn't it be term 13? Let me explain. If we look at this sequence over here, what is this term number? It's term number 6. 1, 2, 3, 4, 5, 6. But in its own sequence, 1, 2, 3, it's term number 3. It's half, because we're removing half the things. So term 26 inside here would actually just be term 13 in its own sequence. Make sense? So don't put a 26 here, because then you are saying that there are 26 terms in the geometric formula, because this is a geometric. There's only 13, so we're going to go find term 13 over here. Let's write it here. Now, what is A? Don't put X. Remember, this is the geometric sequence. So A is term 1 inside its own sequence. There's a couple areas here where learners can get confused. And then R, what is R? Well, I showed you how to get R earlier. We said that it was 1 over 3, remember? When you say term 2 divided by term 1, use these ones. Don't use these ones, because we're looking at specifically the geometric. You would say 1 over 9 divided by 1 over 3, and that would give you 1 over 3. And so R is going to be 1 over 3. Now, N is going to be 13, right? We're going to say 13 minus 1. Fantastic. It's a very good question. That question right there tests the depth of your understanding. Because it's very easy to just be like, oh, aware, brew, A. Yeah, yes, this brew. I know this stuff. A is always the first term. And then N, yeah, of course, brew, 26. You got to be careful. You got to think carefully what you're doing, okay? So, always whip out the Josie accent. Even though I've probably been to Joburg like twice in my whole life, but for some reason I always go there mentally. 13 minus 1. Some of you are like, Kevin, wait, you've only been to Joburg twice. Bro, are you even South African? Where do you live? I'm a Cape Townian, brother. And then 13. Oh, what an ugly answer. It's 1 over 1594323. 1594323. You can also write this in a different way. I think one of the other answers was like 6.27 times 10 to the negative whatever, something. That is also sufficient, okay? And then, so we've done that one. Okay, let's create a bit of space here. I should win an award for how tidy I am. I've never seen someone as tidy as me. Okay, no, that was obviously a joke. I know I'm not the most tidy, guys, but I'm always trying my best. Always gonna try to be better. Okay, I don't know what accent I was even going for there. Thing was like, I was going for like a little goody two-shoes nerd. Just love to do mathematics all day long. Okay, wow. Right, so then calculate the value of P26. I've become so conscious of not making too many jokes anymore because I've had so many memes on TikTok made. Well, not so many, I mean, I'm not like Justin Bieber here, but I've had like 3 or 4 memes of people making jokes. Not jokes, but like, it's like passive aggression I see in their videos. They make funny videos of like, it's 2 o'clock in the morning and Kevin's out here making jokes. And then they make videos on TikTok of their frustration at that. So I've become conscious about it now. So I tried to not be myself anymore. Just do serious maths all the time. All right, next question, 2.2.4. Okay, no. Obviously, I always try to add a bit of my own, I've got my own little, I like to add my little jokes in there, but yeah, I don't know if you've seen my video. Can't remember what video it was, but I start the video, I think it's an exam paper, and I go on a rant for like 10 minutes about coffee. Yeah, I mean, some learners weren't very impressed. I can understand it though, like if you're sitting right now and you have a test in like 3 hours, and then you've got this bully on the other side of the internet who's busy talking about the most random SHIT, then yeah, I guess it could get frustrating. So I do apologize. All right, so then Kev, let's move on. You're doing it again. So calculate the value of P26. We've done that. We now have 1 over 1594323. Okay. Determine the general term. We've done that. Okay, so now we are over here. If this ugly expression is that, determine the value of x. Right, now, I've mentioned this a lot of times. Learners get super caught out in these questions. They think that Pn is equal to 33.5. That's what learners do. They think that that is what that is over there. So then what they go do is they go make this expression equal to that. But that is not what they're saying. They are saying this is equal to 33.5. Some of you are like, Kev, what's the difference, bro? Like, what does it matter if I include that one or if I do that one and that one? No, it's a huge difference, brother. This part, when you include this part, it means the sum of. Whereas if you just use this part, it just means the sequence. But when you have the sigma, it's sum of. Okay, Kev, whatever, bro. Okay, let's carry on. So, right, where are we? Determine the value of x. Okay, so they're saying that the sum of this expression up to 21 terms. How do I know it's 21 terms? Is it because there's a 21 there? Well, not actually. It's because there's a 21 there and this number is a 1. But if this number was a 2, then the number of terms would not be 21. I've showed you how to do this before. To work out the number of terms, it's always, say it with me, top number minus bottom number plus 1. And so in this case, it would be 21 minus the bottom number, which is 1 plus 1. So in this case, the 1's cancel out, and so you end up with 21. And the problem is that most of your teachers, when they show you this in class, they always give you examples where this number is a 1. And so in your head, you have now subconsciously you've been made to believe that this number represents the number of terms. But it's only true when this number at the bottom is 1. So just rather remember this, okay? So there are 21 terms. Determine the value of x. Right, so what you need to understand is that the sequence goes x, 1 over 3, 2x, 1 over 9, 3x, 1 over 27, then it goes 4x, 1 over 81, then it would go 5x, and then it would go 1 over 243, then 6x. No, I'm not going to do the whole thing. Okay, so they want to know what is the sum of, well, they told us the sum of 21 terms is 33.5, and from that we'd be able to work out x. Okay, let's get rid of all of this. So 21 is a bit of an awkward number, because if they said 20, then we would say, oh, well then that obviously means 10 of the arithmetic, and then 10 of the geometric. But when they say 21, what do? Do you say 10 and a half of the one and 10 and a half of the other? No, you can't. So how do you know? One of them is going to be 10 terms, and one of them is going to be 11. Well, the one that starts first will always be the one that's more. I'll show you an example. Let's say they said there were 9 terms. So 9 terms goes up to 4, 5, 6, 7, 8, 9. 9 goes up to here. So you would see that the one that's first will probably be 5 terms. 1, 2, 3, 4, 5. And then the other one would be 4. 1, 2, 3, 4. You see what I mean? When they give you an odd number, then the sequence that starts first would always be the more powerful one. So that means there's 21 terms. So that means it's going to be 11 of this one, 11 terms of the arithmetic, and then 10 terms of the geometric. So that's going to be 11 terms arithmetic plus 10 terms geometric. All right. So what we can now do is we can go do the sum formula for the arithmetic plus the sum term of the geometric. And we know that the answer of all of those, this one will be for 11 terms, and this one will be for 10 terms. The answer must be 33.5. So let's get rid of this. I need a bit more space. So we know that the sum of an arithmetic is, we know it's this formula, n over 2, 2a plus n minus 1 times d. And then we know that the sum of a geometric is a bracket 1 minus r to the power of n over 1 minus r. You can also flip the 1 minus r to r minus 1, but then just make sure you do it at the top and the bottom. Then it works out perfectly fine. Okay, so I'm just trying to think of my space here. Okay, so for this one, I'm going to write it over here. So it would be, we said it's going to be the arithmetic, which is going to have 11 terms. So the sum of 11 terms would look like this. Now, what is a for that sequence? It was x, right? Or you could say x over here. So x, 11 terms. And what was the common difference? Well, I showed that to you earlier. We said it was just x. Remember that? So we can just do that and then close the bracket. Okay, so that's what that expression would look like. We could go simplify it a little bit. So 11 over 2 is 5.5. 2x plus, now this is just 10. So this will just be 10x. 10x. And so 2x plus 10x is 12x. And then if you just multiply 5.5 with 12, you get 66. So that's going to be 66x. Some of you are like, Kev, shouldn't you multiply the 5.5 with the x as well? We just have to do it all at once. But what you're thinking of is this. I've had this question a lot. You're thinking of that. Okay, not the same. All right, so we now know that this one is going to be 66x. So we can sub it into here later on. Then I'm now going to go work on... Okay, sorry about the space issue, guys. Okay, so I'm going to use this one now over here. And so it's going to be 10 terms, because remember, we're only using, we said it's only going to be 10 terms for the geometric. So remember, for a now, you're not going to say x, you're going to say 1 over 3, because we're using term 1 of this new pattern of the geometric. And then r, we worked out earlier, is a third, and then the number of terms is only going to be 10. Don't say 26, don't say 21. It's got to be the sequence that you are working with at that time. Okay, S10. And then at the bottom, we're just going to have 1 minus a third. Now here we have no variables, so you can go type that all in on your calculator. Okay, and we can just round that to 2 decimal places. It's just going to be 0, 5, 0. Because it was like 0, 4, 15325. So we can just round that to 0.5. Right, now we can come back to this little equation over here where we said that the two sequences added together must give us 33.5. So for the arithmetic, we got it as 66x. And for the geometric, we got it as 0.5. And look how simplified that is now. So now we just take the 0.5 over to the other side where it becomes a minus. So 66x equals 33. And then don't say the answer's 2. A lot of you are going to look at this and your mind is immediately going to think, oh, 2. And you're just going to say x is 2. But be careful. X is going to be 33 divided by 66, which is actually a half. A quadratic sequence has the following properties. The second difference is 10, the first two terms are equal, and term 1 plus term 2 plus term 3 is 28. Show that the general term is that. Okay, now what a lot of learners do, and it's not correct, they take this and they start using that to prove these things. You're not going to get any marks for that. Leave this alone and work with this and see if you can make what they want. Okay, so we've got the sequence. They tell us that, okay, let's say we had this random sequence, x, y, z, for example. They tell us that the first two terms are equal. Okay, so I'm going to make these two both x. And then it says that term 1 plus term 2 plus term 3 equals 28. So term 1 is x, term 2 is x, term 3, let's make this a y actually. Well, no, we can leave it as z, whatever, equals 28. So then z, if you had to solve, would be 28 minus 2x. So now I can replace this with 28 minus 2x, okay? Now, I can go down to the first difference. That would just be 0. And then I can go down to here. So remember, to work out your difference, you always take this one minus this one. And that would give you 28 minus 3x. Because it would be 28 minus 2x minus x. Okay, now if you had to go to the second difference, they told us that that is 10. But how would you normally do the second difference? You would take this one minus this one. So we can say 28 minus 3x, take away 0, and we know that the answer should be 10. And so if you then take the, however you want to solve this, that would just be that. And then if I take the 3x to this side and I take the 10 to this side, then 3x would be 18, so x is 6. There we go. Now that we have x, we can construct this now. So we can say that x is 6, so term 1 is 6, term 2 is 6, and then this would be 28 minus 2 times 6, which is 28 minus 12. What is 28 minus 12? 16. And there we have the first 3 terms of our sequence. Notice how we didn't even look at this nonsense over here. So never take what they want you to prove and then use that to try work backwards. I know it's nice, you're like, oh, brew, easy, I'll just sub in values. No, they won't give you marks. That's the problem. Okay. Now, if we have 6, or let's actually just keep it up here. If we know that this now, the difference is 0, here the difference is 10. Oh, that's also 10. That's interesting. And then here the difference is also 10. Now we know how to make the formulas. We know that we can say that this one is equal to 2a. We know that 3a, well, okay, if not t, 3a plus b is that one. And then a plus b plus c is that one. So if 2a is 10, then a would just be 5. Now we can work over here. So we can say that 3a plus b equals 0. So 3 times 5 plus b is 0. So if you had to work out b, you would get negative 15. And then a plus b plus c is 6. So a is, we said, was 5. B is negative 15. And then c. And then that's all equal to 6. So this would be negative 10. And so if you had to work out c, you would get 16. And so we know that the formula of a quadratic is an squared plus bn plus c. So a is 5, b is minus 15, and then c is 16. And there we have it. That was a good question. Okay, I'm just going to clear up some space so we can do question 3.2. This next one says, is the number 216 in the sequence? Well, a lot of learners, they're going to go put the number 216 over there, but that's not correct. If they're saying, is 216 a number or a term in the sequence, you're going to put the 216 over there. So you're going to say 216 equals to, and now you're just going to solve and see if n can be a possibility. So solve this however you feel comfortable, but I'm going to take everything to the right-hand side. And then this will become plus 16 minus 216. And that will then be minus 200. Let me double check. Don't want to make any silly on-camera mistakes here. Minus 200. Yeah. Okay, now you can solve this however you like. I'm going to divide everything by 5. You don't have to do that. I just feel like doing it. And so n squared, take away 3n, take away, what's that, 40? Let me double check. 40. Okay, now you can use quadratic formula here. I'm going to just factorize it, but you can use quadratic, not a problem at all, the quadratic formula. So this would become n, take away 8, n, add 5. How did I do that? Well, I know that 8 times 5 is 40, and I know that minus 8 plus 5 gives me minus 3. Okay, obviously, guys, I've been doing this for years and years and years and years. You guys have other subjects, so you don't have enough time to go into it the way I've been able to. So if you ever see me doing factorizing quickly or whatever, that didn't come automatically. That just came from years and years and years of teaching this and doing this, okay? So if you just want to use the quadratic formula in the test and you don't even feel comfortable dividing by 5 because as soon as you start thinking, wait, can I divide by 5? You start doubting your life choices and just use the quadratic formula. Honestly, it's fine. In school, you don't get enough time, I believe. There are some people that can, you get those learners who do like 15 subjects and they just always seem to get like 98% for everything. And their blazers, like, they have to order a second blazer because they just can't fit all the badges, Like those learners, I don't know, they on another level. They're like Elon Musk type vibe. But I wasn't like that. Like, I don't think I even got one badge in my whole life. So, I think I was a prefect in grade 7. # winning at life. Where was I? So now we can just solve. And so we're just going to say n minus 8 equals 0, or n plus 5 equals to 0. So n is 8, or n is minus 5. Now, what is n? N is the number of terms. So you can't have a negative number of terms. You can just say like NA for this one, therefore n is 8. What that means is that if we had to carry on with that sequence, we had that 6, 6, 16. If you had to keep going and you get to position number 8, there would be the number 216 over there. So because we got a nice answer and we didn't get some answer like 3.1689, because you can't have 3.1689 as a term number. This is term 1, this is term 2, this is term 3, this is term 4, term 5. You can't have term 3.1689. You can only have a whole number of terms. So because we got a nice, beautiful answer, we can say, is 216 a term in the sequence? You would then say, yes, 216 is a term. Okay, after you obviously solved, right? You can't just go straight there without showing you're working out. Given the function p is equal to a third x. Now you should immediately know that this is exponential. Exponential. Okay, so and then it says, is p increasing or decreasing? Now a lot of learners, they'll tell me, because this is a fraction, that means it's automatically decreasing, and they'll say that it's automatically going like this. But it's not correct to say because it's a fraction. I could give you a fraction like this. I could say f of x is equal to 9 over 8. And guess what? This one is actually increasing. Why? It's because if you type this number on your calculator, you'll see that it is larger than 1. So when the number is larger than 1, then it increases. When the number is smaller than 1, then it will decrease. So if you had to go type this in your calculator, it would be like 0.333333. So it's smaller than 1, so it would decrease. However, if you are in an exam and you just cannot get your mind to understand or remember, then all I want you to do is just plot 3 points. So you can choose any x value that is negative. So let's maybe say -3. So you'll plug -3 there. You don't have to show the examiner this part. It's only for 1 mark. You can just do it on a side piece of paper. Plug in, or better yet, just take a rough piece of paper with you into the exam with all the notes. Okay, I'm joking. Obviously, that's illegal. Just say a third, and then plug in x as -3. Let's plug in x as -3. And what that gave me was 27. Okay, so when x is -3, the y value is 27. So that's a really high value, okay? Then I want you to just plug in x as 0, for example. So plug in x as 0, and you're going to end up with 1. And then plug in x as 2. Because you see, I'm trying to find something here, and something here, so I can get an idea of the shape. Then plug in x as 1, and you're going to get a third, which is even lower than this. That's like there. And there I can tell that this is a decreasing function. Oh, nice, Kev. Thanks. So it would be decreasing. But if you want to just remember this, if this number is less than 1, then it decreases. It's got nothing to do with a fraction. Because as I just told you, I can give you a fraction that is larger than 1 if I really wanted to. So don't think of it as fraction, not fraction. Okay? Now the next question says, determine the inverse. Remember, this doesn't mean the first derivative. First derivative doesn't have a -1 like that. It has a little thing like that. Can you remember what the inverse of a exponential graph becomes? It's a log graph, eh? Well done if you remembered that. So, but how do we convert it? Well, let's go write down the first equation so long. Okay, now let's change this to y. Now, how have I taught you how to do inverses? First step, switch x and y around. Okay, so we just switch the x and y around. Next step, get the y value alone. Now, it's going to be a log because we've learned that the inverse of an exponential is a log, and the inverse of a log is an exponential. Logs and exponentials, they are like family members. They convert between each other when you do inverses. Okay, don't forget that. Log, exponential. Log, exponential. So, you need to know how to get logs. So we're trying to get the y value alone. So I'm going to say y equals. Then I'm going to say log. Then this number is the base over here. So it's going to be the base of the log as well. So the base stays the base. And then I'm just going to put x. And there is my answer. So the third is down here. It's down at the base, and then the x is over there. And so let's just go write that in. Y equals to log of a third times x. Then it says write down the domain of the inverse. Okay, now what have I taught you about inverses? Remember, when you take inverse, x becomes y, y becomes x. So, domain becomes range, well done, and range would become domain. So they said, write down the domain of this graph. So that means we can go back to the original and we can find its range, because the range of this one becomes the domain for this one. So let's go back to this one now. We're going to focus our attention on this exponential. It's a basic exponential that does not have any plus or minus over here. That means the asymptote is the x-axis. If there was a plus 1, then the asymptote would be over there at 1. If it was a minus 3, then the asymptote would be at minus 3. But there's nothing over here. It doesn't mean there is no asymptote. It means the asymptote is on the x-axis. Now we said it's a decreasing, so we can just go draw it like that. And so that's what this graph looks like. So what is this graph's range? Well, range is the y values. So it would keep going down, 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 and it would get very close to 0. So the range would be that the y value must be larger than 0. So we'd say y is bigger than 0. If you prefer interval, you would say 0 up to infinity. Round bracket, because it doesn't touch the 0. So now this becomes the domain, but because it's domain, we change it to x, and we just do that. Or you could say x is bigger than 0. You see how the range of the one graph becomes the domain, because x's and y's switch when you do inverse. Okay. Just want to quickly come back to this question. I just remembered that a lot of learners, what they like to do is, and you don't have to do it this way, but what they do is the following. They change this. They don't like to have this fraction over here. So what they do is they change it to 3 to the negative 1, because 3 to the negative 1 is the same as 1 over 3. Then they distribute the negative outside, so they end up with that. And then they then go do the whole switch x and y around. And then they end up with minus y equals to log 3 of x. And then they just put the negative on the other side. And they end up with that. So this is the same as that. So you are welcome to do it that way as well. And that was for this question, okay? Right, so we've done this one now as well. So now we need to do this one. Write down the equation of the asymptote of p if you move p5 down. Very easy question. We know that the asymptote at the moment is on 0. We said that earlier. It's over there. So now they said write down the equation of the asymptote of p, so this graph's asymptote, if you move it down by 5. So the asymptote will just move down by 5. So if you have a graph where you've got an asymptote down here, then that is just y equals minus 5. How do I know it's y and not x? Well, all I do is I look at the intercept and I ask myself, is that intercepting the y-axis or the x-axis? That's intercepting the y-axis. So we say y equals negative 5. Given f of x is equal to, okay, so here we have a hyperbola. We must understand that that is a hyperbola. Write down the equations of the asymptotes. So remember that your asymptotes are found here. Let's do that a little bit better. Here and here. Remember that if you have x minus 1, it means that the graph has moved one place to the right. So if you had a normal x and y axis, then your graph has moved one place to the right. So the asymptote will be one place to the right at x equals 1. And your y asymptote has moved up by 2. So it would be there. Y equals 2. And so those are the equations that they are talking about. X equals 1 and y equals 2. Remember that with x, it's all opposite. So I know that here I said minus 1, but here I said 1. But this means the graph has moved one place to the right. With x, it's always weird. Okay. Calculate the x-intercept. Now, to find x-intercepts, we know by now that we make y 0. So we're going to say 0 equals to 4 over x take away 1 plus 2. Multiple ways you could solve this. I'm going to take this to the other side. Now, whenever you have an equal sign like this, then you can do cross multiplication. So, because you're multiplying across the equal sign. So I'm going to multiply this up to there. So we end up with that. And then I'm going to end up with minus 2x plus 2 because I multiply this in. And then I end up with 4 over there. And then it's just a matter of solving however you want. So I'm going to leave the 2x on this side. Take the 2 over where you'll end up with 4 minus 2, which is 2. Divide both sides by negative 2. And so x will be negative 1. So don't just say negative 1. Always say negative 1 and 0 for the y value. Sketch the graph. Okay, so we've learned that to sketch a hyperbola, we need the asymptotes. Let's just go draw a random little hyperbola. A random one, okay? I'm not saying the one we have is going to do the same. But look at what we need. We need asymptotes. We've got those. We need x-intercept. We've got those. So what are we missing? A y-intercept. So let's just go get our y-intercept quickly, and then we have everything. There's no turning points for a hyperbola. So to find a y-intercept, you make x 0, and this will give you, if you just go type that all in, it'll give you negative 2. And so your y-intercept is then going to be x. You'll write your y-intercept as x as 0, like we said, and then the y is negative 2. Okay, so now we can go draw the graph. And so what you would get is we've got the asymptotes at x equals to 1, the y asymptote, as y equals to 2. Your x-intercept, negative 1 and 0. Just fill that negative 1 and 0. Hey, where are you going? And then the y-intercept as 0 and minus 2, which would be somewhere here. Okay, let's just write this a little bit differently. Okay, so you're going to get a graph that's going to go something like that. And then always on the opposite side. So the opposite side would be there. So you just draw another one. Okay, that's it. So it goes up along this asymptote and along that asymptote. And so there we have it. The next question says, use your graph to determine this ugly expression. Okay, now what you got to understand is that this expression is often going to be a manipulation of that. So if I take this equation and I then take the minus 2 over, some of you are like, Kevin, shouldn't we change the sign? No. We only change that sign if we divide by a negative. We're not dividing here. We're just taking the negative number over. We're just moving it over, okay? And so what we now have is the exact equation. Check there and there. So what they're now saying is, where is this equation, which is this graph, where is that bigger than 0? Now, what does that mean? It means, when they say that, it means above the x-axis. So here's your x-axis. So where is the graph above? Well, that would be here. You can see it's above, and it would also be over here. So you could say it's when x is smaller than this number, which was minus 1. I'll show you interval and set builders. You could say x is smaller than or equal to minus 1, because they've used the equal to as well. But just be careful. You don't want to choose a number that makes this denominator 0. But I think we'll be fine because, well, I know we'll be fine. Geez, it would be bad if your math teacher was like, I think it should be fine. No, I'm 100% sure. If x is minus 1, then this becomes minus 2. So there's nothing wrong with that. So that's our first part. And now we're going to go from this part. So it's going to be when x is larger than 1. But here, we're just going to say that. We're not going to say and equal to, because you can never make your asymptote and equal to. And if you did, if x was 1, then this denominator would become 0. And you're not allowed to have a 0 in the denominator. So that's the answer. But if you prefer interval notation, you could say x is an element from negative infinity up to negative 1. That's for this part. Or we go from 1 up to infinity. And that's for that part. So my advice is, whenever you get something like this, It's not always the case, but many times it is that you can convert this somehow to be that. And then it's easy, because then if you have this, then you know it's the graph. Okay. Now, that's that. Now we're doing this one. Determine the equation of the axis of symmetry. Now, axis of symmetries are the lines that go through here, like that and like that. And we know that this one always has a gradient of 1, and this one always has a gradient of -1. Always. But now they say determine the axis of symmetry of the graph f, which we have, after the graph f has moved x minus 2. So that means 2 places to the right. So that means that if this point here, what are the coordinates of this point? The coordinates of that point will be x is 1 and y is 2. But what would those coordinates be if you move 2 places to the right? Well, then it would become 3 for the x value, but the y value will still be a 2. So we will rather use axis of symmetries going through there. Okay? And so, do they want both of them? Oh, that has a negative gradient. Okay, so that's the negative gradient one. So that's this one here. So the gradient never changes. That'll always be -1. And if they wanted this one, then it would always be +1. So if you go y equals to -1x plus c, then you're just going to find c, you're just going to, instead of plugging in this value, you're going to plug in this value, which is 3 and 2. So y will be 2 and x would be 3. And then if you had to work out c, you would end up with 2 plus 3, which is 5. And so y is -1x, because the gradient is always -1, and they asked us for the -1, and then plus 5. The graphs of the functions, okay, then they give us a graph of f, which is a parabola. So let's go and do that, and then let's do that over there. And then they give us a straight line, which I'll do in green. Now, are drawn below the graphs intersected A and B. First question, write down the coordinates of the turning point of f for 2 marks. Okay, so if we write out that equation, let's go through this nicely. The negative, now, first of all, this is written in turning point form, right? Remember that an equation can be written in turning point form, which is like that. So the negative in the front, that just tells us that the graph is upside down. So instead of looking like a happy face, it instead looks like a sad face. Can you see the sad face and the happy face? So when this is a positive, it's happy. Positive people are happy. When it's negative, then it's sad. Sad people are negative. Okay? The next thing is that this part over here tells you how far has the graph moved right or left. Okay? So you got to understand or remember that when this is a plus, it means that the graph has moved left. So, and we can see that this graph has moved left, because the yellow one, because if we have a normal parabola that is sad, it would go, okay, let me start in the basics. A normal parabola would go like that. That is like the first parabola we ever learnt about in like maybe grade 9 or 10. Then, if we put a negative, that makes it sad. Okay, sad. Then, if we move it 3 places to the left, okay, so then it's going to move 3 places to the left, so that'll maybe be like over there. And then the plus 4 means it's going to go up by 4. So if we move it up by 4, then it's going to go maybe something like that. And that is exactly what we can see over here. So the negative makes it go upside down. The plus 3 makes it go left. If it was a negative, it would go right. And then the plus over here makes it go up. If it was a negative, it would go down. So now we can easily work out what this coordinate would be, because if it's moved from here and it moved 3 places to the left, then this would be -3. And if it moved 4 places up, then this would be a 4. And so there is your answer, -3 and 4. So we can see it over there, and that is because we call this the turning point form of a parabola. Because why? It gives us the turning point immediately. Okay. Now, this one. Write down the range of f. Okay, so range is the y values. So I'll show you interval notation and I'll show you set builder notation. So you'll say y is an element. Now, what is the smallest y value? Remember, range always goes from smallest to biggest. So if we look at the y values, if you look at these graphs, or this graph, it just keeps going down, 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 down. So that's going to be negative infinity. Now, if you look at the highest y value, it's over here. Can you see it? There. So what is the y value there? 4. And I'm going to use a square bracket because the number 4 is part of the graph. It's not an asymptote. If you did set builder notation, you could say that y is smaller or equal to 4. So it means that y can be anything smaller or equal to 4. So that's the same thing. Now, let's move on to this one. For 4 marks, show that the x-coordinates of A and B, this is a lovely question because we know if we're correct or not. They show that the x-coordinates of A and B. Okay, so A and B are the places where the graphs are intersecting. To find the intercepts, or the place where two graphs go into each other, all that you do is, when it's written out like this, you can just make these two equations equal to each other. So we can just say minus x plus 3 squared plus 4 equals x plus 5. Now, listen carefully. There is a place over here where 50% of learners will get this part wrong. You're not going to put the negative inside this bracket because of this 2 over here. So what you're going to do is just put the negative. Now, this 2 is only for the bracket. So how many brackets are we going to make? 2. There we go. That's how you write that part out. Then you're going to say plus 4 equals x plus 5. Now, here's another place where learners make mistakes. They get a bit confused over here. What I would suggest, just leave this negative alone. Then let's multiply these two brackets together, but keep the answer in a bigger bracket so that we can put the negative in the next step. Okay, so x multiplied by x is x squared. X multiplied by 3 is 3x. This is also going to be 3x. And then 3 times 3 is not 6, it's 9. I know in a test sometimes learners are like 6. Probably because I did that once or twice. Equals to x plus 5. Okay, next step, we can now distribute the negative into all of that. So, negative x squared, take away 3x, take away 3x, take away 9, plus 4 equals x plus 5. Now it's just a quadratic equation. You can either take everything to the left or you can take everything to the right. It doesn't matter. So I'm just going to bring everything over to the left. So we're going to have negative x squared. Now these two together are going to make negative 6. Not positive. You might say, yeah, but Kevin, there's a negative and a negative. I agree, but we're not multiplying. We're just collecting like terms now. So this would be negative 6. And then if you had to bring this 1x over, it would become a negative. So you're going to end up with negative 7x altogether. And then here we have negative 5. Then we're going to bring this over. It will become a negative 5. So we're going to end up with a negative 10 equals 0. Okay, now there's multiple things we could do here. We could use the quadratic formula just like this. But what I want to do is, I don't like this negative here. So I'm going to divide everything by negative 1. Okay. I know you can't see that there's something over here, but I've just divided everything by negative 1. So that's going to end up giving us a positive x squared, a positive 7x, a positive 10, and then 0 will just stay 0. Here you could use the quadratic formula, but this one can also factorize very nicely. We don't need such big brackets, my bro. So we could just say it's x plus 5 and x plus 2. And so you could say that x plus 5 is 0 or x plus 2 is 0. Therefore, x is negative 5 or x is negative 2. And that is exactly what they wanted us to show. They only wanted the x-intercepts. So the x-coordinates. We don't need to go get the y's. And so we've done that question. Now, this next question, if you just read it, it's enough to really make you feel a bit nervous in a test, right? Now, if you are in a test and you read that question and it makes you feel a bit unsettled, then if you're a student that gets like 30, 40, 50, 60%, you don't have to do that question. You know, it's only worth 2 marks, and I don't want you to, in an exam, sit and waste like 20 minutes on something like that, because that's going to have a serious consequence on your next questions that you have to answer, because now you've limited your time and it was only ever worth 2 marks. So in an exam, I want you to carefully weigh up what you need to do, because you might say, yeah, but Kevin, I need to do all questions. But I disagree, because if you did all questions, and if you did all questions perfectly, you would always have 100% for your exams, and you don't. So I would say that you need to be strategic about what you do. You need to understand that you're not a 99% student, and some questions you can just leave out because it's only worth 2 marks at the end of the day. All right, but let's do it anyways. It will be a bit awkward if I just said, okay, guys, let's go to the next question. So, hence, determine the value of c for which this ugly equation has 1 negative and 1 positive root. Okay, let me explain. Now, listen up carefully. Can you see that this part over here is the same as this over here, but all that they've done is they've added the plus c over there? All right, and then this part over here is the same as this part over here, but all that they've done is they've added the plus c with the x. Can you see the plus c has been added with the x in both of them? Okay, so we know that when you make the 2 equations equal, I'm just going to use these 2 equations. We know that when you do that, just like we did over here, what is this helping us to solve? It helps us to solve where are the 2 graphs intercepting. Okay, so the next thing we need to talk about is, what does this do? Specifically, they're adding it to the x. So if I gave you an equation like this, y equals to x squared plus 1, as an example, this would be a normal parabola. Now, what would happen if I changed the x to that? What would this part do to the graph? It would move the graph either left or right. Whenever they change something by the x, it changes the graph left or right. If it's a minus, it means the graph goes to the right, and if it's a plus, it means the graph goes to the left. So, this c value over here is taking this equation, which is this parabola, and it's either going to move it left or right. Some of you are saying, Kevin, it's going to be left because it's a plus. Yeah, not really, because what if c is a negative value? So we don't know right now. C might end up being a negative. So all I want you to know for now is that this part here is taking this graph and it's moving it left or right, and it's taking this graph and it's moving it left or right in the same direction, because c is going to be the same for both. So what they are actually doing is they're taking all of this and they're moving both of the graphs together, left or right. And they want us to move it so that you're going to have 1 negative and 1 positive root. A root is the same as an answer. So we said that when they make the 2 graphs equal, they are trying to find out, where do the 2 graphs intercept? So where do the 2 graphs intercept at the moment? Well, this was -5 and this was -2, as we have just seen over here. So the answers are both negative. But they want one of the answers to be a negative and one of them to be a positive. So what should I do with this over here so that one of them is a positive and one of them is a negative where they intercept? Well, what I could do is I could take the entire system and I could move it over a little bit to the right, so that this part over here ends up being on this side of the y-axis, because then it will have a positive x value. So we just need to move it 2 places. We just need to go 2 places this way, okay? We could go 2 or more. So if we go 3 places, then it would end up over here, but 2 is the minimum, because if we move it 2 places, then we will be on the y-axis, but we want to be just next to the y-axis. So C, we would want that to be a -2 or maybe a -3 or maybe a -4, because when it's a negative, it means we're moving to the right, and we want to move to the right. So we want C to be any number smaller than -2, because smaller than -2 would be -2, or sorry, -2 is not included, but -2.1, -3, -4, -5. So if you have like a -5 over here and here, then it means 5 places to the right. So then you would move like that. However, if you move too far, then this part over here is also going to end up being on this side of the y-axis. And then you're going to have both of these answers are going to be positive. But they want one of them to be negative and one of them to be positive. So we don't want the C value to go smaller than -5. Like, you don't want it to be -6. So we're going to say that C must be smaller than -2, but it must be bigger than -5. So you want it to be anywhere between those two. If you prefer interval notation, you could say that C is an element from -5 to -2. It's quite a difficult question, that one, but I hope I've helped you to understand what they meant. Now, this last one, for 5 marks, says says that the maximum distance between F and G in some interval over here, don't worry when you look at that, I know it doesn't look nice, is K. The maximum distance between F and G between A and B is K. If H is equal to that, determine the equation of H in the form. Okay, so this looks horrible. I totally agree. But I'll show you. It's actually quite an interesting question. Okay, so what we've learned in the past, let's just try and neaten up a little bit over here. Okay, what we've learned in the past is that when you have like a parabola and a straight line, if you look at the vertical distance over here, you can see that it's increasing, it's getting more, and then it starts to become less. So there is a place somewhere in between where the vertical distance is a maximum. And a lot of learners always tell me, oh, it's by the turning point, isn't it? No, it's not true. It's not necessarily at the turning point, okay? You can see that that distance there is probably not as long as that distance there. I mean, it might be, but it's not necessarily at the turning point, okay? So they're saying that the maximum distance between F and G in the interval when X is anywhere between the A value and the B value, they're talking about this A and this B. So somewhere in between here to here, there is a place where the graph or the distance between them is a maximum. And I've spoken to you about this before. If you are in grade 12, you can definitely use calculus because they're talking about maximum. I'll tell you when to do that now. But if you are in grade 11, and also if you're grade 12, you can also use the y top minus y bottom technique, which I have taught. Whenever they talk about vertical distance, I always say that, so we can just say that the vertical distance is always equal to the y value of the top graph. What do I mean by the top graph? Well, we can see the parabola is on top, and then the straight line is at the bottom. Okay, so if you've watched my videos on this, you'd know what I'm talking about. What I then go do is I go substitute the equation for each one inside there. So the parabola's equation is this. So I go plug that in, okay? Then I say minus, because there's a minus. I then put a bracket, and I put the bottom graph, x plus 5. And that's equal to the vertical distance. I'm now just going to go simplify this. Some people are like, yeah, so I'm going to go solve it. You can't solve it, because how are you going to solve it? This isn't a 0 on the left. You're just going to go simplify it, okay? Just make it look a little nicer. Vertical distance. Okay, and we're going to go, if you were in grade 12 and you want to use calculus, you would still be doing this part right now. So just like we did earlier, I'm going to go put double brackets, then plus 4. Then I'm going to multiply this in and in. So minus x minus 5. Okay, now we're just going to go simplify. We're not solving. You can't solve. And so we're just going to say x squared plus 3x plus 3x plus 9 plus 4. Take away x, take away 5. Okay, put the negative into the bracket. It'll become negative. These two together will be 6x. But if we put the negative in, it'll be negative. And then that'll become negative 9 plus 4 minus x minus 5. Okay, I'm going to move down to here now. And so that's going to give us negative x squared, take away 7x because of that. And then these two would become negative 10, negative 10. Okay, and that's equal to the vertical distance. I'm just going to say vertical distance like that. Okay, so we're not solving. Please don't make it equal to 0, because then what you are doing is you're saying that the vertical distance is equal to 0, and the vertical distance is only going to be equal to 0 between the two graphs at that point and that point. And then you're just going to end up getting negative 5 and negative 2 as your answer. But that's not what we want to do. So we want this part over here to be a maximum. So if you are in grade 12 and you want to use calculus, you would now use the techniques that we know to find minimums and maximums. And that would be to take the first derivative of this expression, and you could make that first expression equal to 0, because that's how we find minimum and maximum. And then you would get your x value, and then, yeah, I'm going to use the grade 11 technique instead. I'll get that x value, and then I'll show you what you would do with that x value. Okay, so whenever you have a situation like this in grade 11, or if you're grade 12, you're allowed to use this method. To find the maximum, you are going to go and find the turning point of this equation. So how do we find turning point? We use x equals to minus b over 2a. Let me explain. We know that this is a parabola. It's a parabola. It's not the same as this parabola. And it's a sad parabola. So let's say, for example, it looks like that. We want to find the maximum, and so we find the turning point, because we want to find the maximum vertical distance. Okay? So we're going to go plug in our turning point formula, and that's going to end up giving us negative b, which is negative 7. So we put negative 7. A is negative 1. And if you solve this, you're going to end up getting negative 3.5. So they're telling us that it is the x value of negative 3.5, which would probably be, oh, it's exactly in between these two. That is only a coincidence. It is not always going to be like that. So it's at negative 3.5. So that's about there. X is negative 3.5. Okay? So that is where the maximum is happening. And a lot of learners, as I said, always tell me that it's going to be at the turning point of this parabola. But nope, that's not true. The turning point of this parabola was at negative 3. This is negative 3.5. You see? Okay, so we have the x value. So it says the maximum distance takes place somewhere in the interval over there. If h of x, determine the equation of h. Oh, okay, so they want the value of k. So listen carefully. The maximum distance is equal to k. So how do we find k now? Well, check this. We know that the vertical distance, and grade 12s who are using calculus, this is what you guys would do. You should have gotten that answer over there. Now, the vertical distance is equal to this expression. So if we want to know, because this negative 3.5, that's not the vertical distance. That is just telling us where on the x-axis the vertical distance is. But it's not telling us what the vertical distance actually is. Okay? You can't have a negative vertical distance. That negative 3.5 is just telling us where on the x-axis we are operating. Now, to go find the vertical distance, you would go plug it into this equation, because this equation is the vertical distance. Some learners are like, yeah, but sir, can't I just plug it into this equation and then work out the y values and then minus them? Absolutely. But that is sort of what we did over here, and that is how we got this equation. But you can do it like that. It doesn't matter. So to go work out the vertical distance now, we're going to go plug in negative 3.5. It's negative 3.5. Take away 7, and then the x value is negative 3.5, take away 10. Okay, go type it in on your calculator just like that. You should get 2.25 as your answer. So that is what k is. K is going to be 2.25. So now they said if h is equal to the equation of g plus k, then what is the equation of h? Okay, well, that's really easy. Looks complicated, but it's easy. Check here. They said that h is the equation of g. Okay, so let's go get the equation of g, which is x plus 5. and then they just want you to plus k. So we just say plus, and then what's k? 2.25. Now we can just simplify those two. X plus 7.25. Done. 7.25 could also be written as 29 over 4 if you wanted to. A company bought a photocopier for 150,000 Rand on 1 July 2022. They will use the old photocopier as a trade-in when they replace it with a similar one in 5 years' time in 2027. Let's just talk about that quickly. So I want you to imagine it is 2022 and you're working for a company and you purchase a photocopier, or the company purchases a photocopier for 150,000 Rand. They are going to use that photocopier all the way until the year 2027. In 2027, they will buy a brand new photocopier, and they will use this one, which will now be old in 2027, as a trade-in. Okay, makes sense? Let's say you bought a brand new car in 2022 and you want to get a new one again in 2027. When you get a new one in 2027, this will be your old car and you will use it as a trade-in. And it will obviously be worth a lot less than that because it will depreciate. Okay, and the value of a brand new photocopier will be more than 150,000 because of inflation. So guys, this is actually just going to be a perfect sinking fund kind of question. Let me just give you the theory on that once again. All that happens, it's very easy. Sinking funds are very easy. Listen to this carefully. In the year 2022, they buy a photocopy machine for 150,000 Rand. Okay? What is going to happen to the value of that photocopy machine as the years go on to 2027? Is this photocopy machine that they bought now, is it going to become more expensive or less expensive? It's going to become less. Why? Depreciation. Things become old. Okay? So in 2022, they bought a photocopy machine for 150,000. Okay? Let's just say it will decrease due to depreciation. Okay. In 2027, what are they going to do? They're going to buy a brand new one. They're going to buy a new photocopy machine, and it will be more than 150,000. Why? Even though it's going to be the same type. It says here, a similar type. New photocopy will be more than 150,000. Why? Because of something called inflation. You've heard the stories from your dad and your mom, and they're like, yo, back in my day, when I used to buy a Coke, it was only 2 Rand 50. Now it's 23 Rand. Yo, mom and dad, that's just called inflation, okay? That's all it is. So it'll be more than 150,000. And then in 2027, when we buy the new machine, we will sell the old machine. That's what we call a trade-in. Okay, that's called a trade-in. So we'll sell this one in 2027 when we buy the new one. Okay, and then you'll see there's this random... Okay, let me go a little bit deeper into what exactly is the sinking fund, because all that I've explained now is just going to help you with these two. It's going to help you with inflation, and it's going to help you with depreciation. Okay. But what is a sinking fund? Well, let me explain. It's actually really interesting. So, here's an example. Let's say in 2027, this is just an example. Let's say the new one is going to be 200,000 Rand. Because it's worth 100... In 2022, this is the price of a photocopy machine. Let's say in 2027, it's going to be that because of inflation. Okay. Now, in 2027, what will the value of our old machine be? The old machine. Well, it's going to be less than 150 because we said it will depreciate. So let's say it's going to be worth 80,000 Rand. Okay. So think about this carefully. How much is the new machine going to be? 200,000. How much is the old one going to be sold for? 80,000. So how much extra money does the company actually need to pay? Well, if you minus those two values, that is how much the company will need, 120,000 Rand. However, The company would like to save as much money as possible. So they don't want to spend 120,000 Rand. What they rather do, and this is what all companies in the world do because it helps to save a lot of money. In the year 2022, they get one of their fancy actuarial scientists to tell them that they're going to need 120,000 Rand in the year 2027. So what they rather decide to do is they rather decide to take a certain amount of money and they put that into an investment so that the investment can grow to become 120,000 Rand in 2027. But maybe the investment only started with 90,000 Rand. So maybe they only had to put in 90,000 Rand and then the investment will grow to become 120,000 Rand. So they're actually only spending 90,000 Rand to buy the new equipment and not 120,000 Rand because they were investing. And that's the whole idea behind the sinking fund. The sinking fund is the 90,000 Rand that you can invest so that it can become enough that they can replace the photocopy machine in 2027. Okay, these numbers I've used are all just example numbers. We haven't even started with the question. I'm just giving you the background on how sinking fund works. So sinking fund questions usually come in three parts. You need to know what is the new one going to cost because of inflation, what is the old one going to cost because of depreciation, and how much should we invest, or how should we do the investment so that we'll be able to do the purchase in 2027. Okay, and it's three easy parts. I mean, maybe this part might get a bit weird. I'm not sure. They're throwing in some weird numbers here. But let's see how it all goes. So now what's important is, okay, let's start here. The average rate of inflation over the next 5 years will be 6.5%. Determine the price of a new one. Okay, so now this is a grade 11 type of question. So 6.1.1. You're just going to use this formula for inflation, okay? And so you just want to know, what is this going to become in 5 years? It's not compounded monthly. Nope. Inflation and depreciation is always going to be using it's going to be using per annum, not per month. Okay, so we're going to go 6.5%, which is 0.065. You're not going to say over 12 because we're not doing monthly, and then here you're just going to say 5. Not 5 times 12, because that would be months again. And so if we had to go calculate that, we end up with, okay, so it's going to be 205,513, because it would actually round off. The 0.99 would round off. So let's just say here 205,513. This one says, calculate the trade-in value of the old photocopier if it depreciates. Now, depreciation could use two different formulas. Could use this one. Notice how it uses a negative because it's depreciation. Or it could use this one. Now, this one at the top is called reducing balance, whereas this one is called straight line. Now, here they've said straight line. Okay, so we're going to go A equals to P 1 minus I N. And so that's going to be equal to 150,000, because that's what the laptop costs in 2022. And then it's going to depreciate at 9%. It's not per month. You just say 9%. You don't say divide by 12 because it's not compounded monthly. And then you're going to multiply it by the number of years, which is also 5. And that'll give us, the minus is what makes the value go down. 82,500 Rand. 82,500 Rand. Okay, so this is what a new one would cost in 2027, and this is what the old one will be worth. So they can sell this one for 82,500. The company sets up a sinking fund to cover the replacement cost. The fund will earn interest at that, compounded monthly. The company made its first monthly deposit then and will continue to do so until then, 1 month before the new photocopier will be bought. How much should be deposited? Okay. So the first thing we need to do, there's a few little catches in this one. So the first thing we need to do is we need to understand how much money will we actually need. Well, you just need to minus these two, because remember, you're going to sell this one, right? So step one, let's go subtract those two values. Okay, and that'll give us 123,013 Rand. So that is how much the investment needs to become in 2027. So when we go do the future value formula now, let's just go fill in the formula. F equals to x 1 plus I to the n, because we only need that money in the future. We're going to take this and we're going to put it over there, but now there's a little catch. If you've watched my lessons on grade 12 financial maths, you would know that, okay, when should we make our first payment? What have I taught you there? Should we make our first payments immediately or after 1 month? Well, after 1 month, right? So when did they buy this thing here? 1st of July. And when are they making their first payment? 31st of July. So that's 1 month, right? To go from 1 July to 31 July, that's going to be 1 month. So there's nothing wrong with that. That is the correct way to do it. And then what have I taught you? When should the last payment be made? Well, it should usually be made right at the very end. So it should be made there. But when are they making their last payment? There. So they're supposed to make their last payment on the 30th of June 2027, but they're going to make their last payment over there. So how many payments are they going to make? Well, you would normally say 5 years multiplied by 12 because it's monthly. But now because they're going to make their last payment over there instead of over there, that means they're not going to make this payment. So we're going to minus 1. And so we're going to have 59 payments. But there's something else you have to remember. What we've also learned is that if a person misses payments at the end, then we must remember that we need to add a little bracket at the end over here, and we need to put the number of months that they missed. Remember I told you that, because even if a person misses their payments, their money is still in the bank and it still earns interest, and that's what this part does over here. Remember that. So we're going to go put x over here, okay, and then we're going to say 1 plus. Now the interest rate for this one is 7.85%. And this is always going to be monthly. Then we're going to say there was 59 payments. And then, okay, I'm running out of space here. Okay, we said 59 payments. Then we're going to put a bracket. Now, how many months are we missing? Only 1. So I just want you to put a 1 over there. Okay, you're not going to say 1 times 12 because that would be 1 year. And then, of course, we need to remember this part over here. What a lot of learners have done in the past, and I've seen this a lot, is they leave this part out. They work out the value of x, and then they're like, oh, okay, now I'll take the value of x and then I'll add the bracket. Completely incorrect. You have to have it all done in one big formula like that. Okay? Right, now how do we solve this ugly thing? Well, you can go and type all of this on your calculator. Okay, so I'm going to go type all of that on my calculator so long. All right, so if you've typed that all in correctly, we should get 72. Now let's not round off. 19028,178. Now you just need to get x alone. So you would take this number and divide it by that number. And so you should end up with 1,704 Rand and 01 cents. And there we have it. So it says, how much should be deposited at the end of each month? It's that amount there. Today, Andrew borrows 200,000 Rand from a bank. The bank charges interest at that. Andrew will make repayments of 6,000 Rand at the end of every 3 months. His first payment will be made then. How long will it take to settle the loan? Okay, so this is a grade 12 financial maths question. This 200,000, is that money that Andrew will have today or in the future? Today. So we're going to use the present value formula. Oh no, this is just a single bracket. So the amount that he wants to borrow is 200,000. So we'll put that in the place of P. The payment is 6,000. So we'll put that in over there. The interest is 5.25%. Now, they said it's compounded quarterly. So we'll put a 4 over here. And then for the number of payments, remember it's always a negative in this formula. Now, because this is a 4, we're going to put a 4 over here. And then we need to get the number of years. But let's first talk about something. because a lot of learners, they're going to look at this here and they're going to think, oh, he misses 2 payments. But remember, when you are compounding, let's quickly talk about your first payment. If you're compounding monthly, then when should you make your first payment? After 1 month. If, however, you are compounding quarterly, then you make your first payment after, not 4 months, it's 3 months, because there are 4 quarters in a year, but that means every 3 months, 3, 6, 9, 12. So you are only supposed to make your first payment after 3 months, or in 3 months. We could say here in 1 month and in 3 months. And that is exactly what Andrew did. So everything in this question is perfect. So we can simply say 4 multiplied by the number of years, which is x. We don't need to subtract any payments or add any payments because he is following the standard scenario for quarterly compounding. Okay, now the way that we're going to solve this is we're definitely going to have to use logs. So because of that, I don't want you to round off because logs are very sensitive to rounding off. So we're going to take this part and we're going to multiply it up, and we're going to bring this part to the bottom. So that's going to end up giving us 200,000 multiplied by 0.0525 over 4. And then at the bottom, we're going to have 6,000. Then on the right-hand side, let's quickly go type this on the calculator. And that'll give you 1621 over 1,600 to the power of negative 4x. We can keep it in a bracket like that. Okay, then you can also type this on the calculator. So if you go type that on the calculator, keep it as a fraction. So that'll be 7 over 16. So let's actually write that over here. And then 1 minus 1621 over 1600 to the power of negative 4x. Okay, now, because this is negative, let's take it over to the left, and then we'll bring this over to the right. So we would end up with that, and then that. And then this I'm quickly just going to type on my calculator. And if you do that, you would end up with 9 over 16. And now we can use logs. So the thing we're looking for is negative 4x. Then you say log. Then you're going to put the base. 1621 over 1600. And then this part over here. 9 over 16. So you can go ahead now and type all of that on your calculator. And so you should end up with negative 44.1243. We can round off now because we finished with logs. Then to get x alone, you just divide everything by negative 4. And that should give us 11.03 years. This question wants us to determine the first derivative using first principles. Okay, so this is where we have to use the formula. The one that says that the first derivative is equal to the limit as h goes to 0, ooh, it's an ugly arrow, as h goes to 0 of f of x plus h minus f of x over h. Okay, so it's a super easy 5 marks. So I'm going to quickly show you this part over here. Or let me first ask you this. If I said, what is f of 3? Well, then what you would do is you would replace all the x's with 3. If I said, what is f of 7, for example, then you'd replace all the x's with 7. So if I said, what is f of x plus h, like they say here, then you must replace all the x's with x plus h. And so that would look like this. So you'd say minus 2, that's just there already, so you just write that. Then you're going to put a bracket and you're going to replace all the x's with x plus h. I did not change anything else. I only replaced the x. I didn't put a bracket around that. I just bracketed the x. Okay, so that is what you would do. This part, sorry, that part there is what we are going to put over there. Okay, and I'm going to show you that over here. Then the f of x, well, that's just literally this. Okay, and so the way that you would do this is you would say that the first derivative is equal to the limit as h goes to 0. And now we're going to go fill that in. So it's minus 2x plus h squared minus 1. So that's this part. Then I say minus. Then I must use a bracket because I'm minusing f of x, and f of x is this. So I put that in a bracket. There we go. Okay, let's get rid of all this now. And then I'm going to say over h. Now we have to keep saying limit as h goes to 0 the whole way down. And so what we're going to do now is we're just going to simplify. But a lot of learners get this part here. They would get this incorrect. You can't put the minus 2 into the bracket because there is a 2 over here. So we first need to take care of that to the power of 2 part. Okay, so that's going to be minus 2, which I'm just going to leave. Then I'm going to say x plus h and another x plus h. Please don't just say x squared plus h squared. It's not that. You need to make 2 brackets. Then it says minus 1. Then, okay, what I'm going to do now is I'm going to distribute this minus into this bracket. So it's going to go there and it's going to go there. So it's going to become positive 2x squared and then positive 1. Then at the bottom, we've got h. Then we're going to say limit, once again, as h goes to 0. What I'm going to do now, you could multiply this minus 2 into this bracket if you would like. But what I like to do is I first go and do this part. So I keep the answer in a bracket. So it'll be x squared plus xh plus another xh plus h squared minus 1 plus 2x squared plus 1. Next step, limit as h goes to 0. Now I'm going to distribute the negative into the bracket. Whoops, that's a negative. Right. At this step here, we now need to simplify. So we're going to go cancel things out. Now, what is the golden rule that I always tell you guys to look out for? What I say is that anything that does not have an h should cancel. If it doesn't, you have made a mistake. And that mistake could usually be something very small, like not using a bracket. Okay, so have a look here. This minus 2x squared is going to cancel with that that positive 2x squared. This minus 1 is going to cancel with this plus 1, so they would go away. And so everything that we are left with has an h. Can you see that? If it was not like that, you have made a mistake. So what we are left with is minus 2xh minus 2xh. I'm just going to call that minus 4xh, actually, okay? Just to save a bit of space. Minus 4xh and then minus 2h squared. Now, take out a h as a common factor at the top. So I'm going to carry on over here. So equals limit h goes to 0. So you take out an h as a common factor. Then you're left with minus 4x minus 2h. Now the reason that we took out h as a common factor is so that this h and this h can cancel, and then we can now let the h become a 0. We were not allowed to let the h become a 0 in any of these steps. Why? Because then you would have had an h or a 0 in your denominator, and that is not mathematically allowed. But now, all of a sudden, let's just simplify or write out our simplified answer. We now only have minus 4x minus 2h. So there is no denominator with an h anymore. So now we don't need to write this part, and we can let the h become a 0, and we end up with negative 4x. And if you took the first derivative of this in the very beginning, you also would have got a negative 4x. So those two answers should always be the same. But of course, when they ask you to use first principles, then you have to do it the long way around. This question, for only 2 marks, wants us to determine the first derivative if we have that. Okay, so we are told that f of x is equal to minus 2x cubed plus 3x squared. Now, they want us to find the first derivative. So all you do is you take this 3, multiply it with whatever's in the front. So that'll give you negative 6x, and then you subtract 1 from this exponent. So that'll become a 2 plus. Then you're going to do the same. You're going to take this 2, multiply it to the front, which is a 6, subtract 1 from the exponent, so it'll become a 1. But you don't have to put the 1 there because x is the same as x to the power of 1. And so that would be your final answer. It's only 2 marks. Whoops, it's only 2 marks, so it's an easy one. This one wants us to determine dy over dx. Now, what is that? Well, remember, in grade 12, we've learnt about calculus, and we've learnt about the first derivative. Now, there are 3 different ways that they could ask you to find the first derivative. If they used give you a quick little crash course here. If they say f of x equals to 3x plus 1, then if they wanted you to find the first derivative, they would do it like this. They would say, what is that? Now, if they write it as y equals to 3x plus 1, then if they want you to find the first derivative, they can't do this, and they won't do this. No, they will say dy over dx. Okay, it's the same thing though, it just means first derivative. And then the other way that they can do it is using the d notation, like the capital D. So they'll do something like dx, and then in brackets they would have like 7x minus 2, or let's plus 1. All three of those are actually the same thing, just using different notations, but it actually just means first derivative. So because they're using the y, that's why they've got dy by dx. Okay, so what we're going to do, let's go write out their equation, 2x plus 1 over square root 4x. Now, we're not going to go straight into dy by dx. No, we first need to neaten this up, make it look better. We don't want to have this in the denominator. We need to somehow get that up. But if we notice, we know what the square root of 4 is. The square root of 4 is 2. So what we could do is take it out of the square root, and then you'll just have that inside the square root. Okay, so I took the square root of 4, which is 2, and I put it on the outside, but I don't know what the square root of x is, so I just leave it inside the square root. The next step is to do the following. X in a square root, anything in a square root is actually just the same as x to the power of a half. So in the next step, I'm going to take that half up to I'm going to take this x up to the top. So all that happens is the 2 can stay where it is. That's just a random little number. But I take the x up to the top and I make it a minus half. Okay? Now, I'm going to write this in a little bit of a different way. So I'm going to write it as 2x plus a half. That half is that part over there. And then I'm just going to put the x in the front of it like that. Okay. Now I am in a position where everything looks good. I can now go take the derivative. So I do dy by dx. And so now I just do the normal thing. So I know that there's actually a 1 here. I'm going to multiply that with this number in the front. And then I subtract 1 from here. So that'll just become a 0. But x to the 0 just falls away because that just equals a 1. So you just let that fall away. Now I do the same with this part. This multiplies with that. So it's going to become negative 1 over 4, and then x. And then what we're going to do is we're going to take this and we're going to subtract 1, okay? And so if you do that on your calculator, you're actually going to end up with negative 3 over 2. Now, back in the day, a couple years ago, they always wanted us to they never wanted us to have an answer where this was a negative exponent. But nowadays, they actually accept that. And so you don't have to go extra steps after this to make the exponents be positive. You can leave your answer just like that. The graph of y equals to the first derivative, okay, has a minimum turning point at 1 and minus 3. Determine the values of x for which f is concave down. Okay, so this is quite an interesting one. So they're telling us that there's a graph of f of x, okay? So it's not the graph of f of x like that. It's the graph of the first derivative, okay? Now they tell us that it has a minimum turning point. Okay, so it's going to be like a parabola with a minimum. Now to have a minimum, must your graph do this or must your graph do that? Well, this is a maximum because it's high up, and this is a minimum because it's at the bottom. So if it has a minimum, then it's a graph that does this, and they're telling us that it has a minimum at 1 and minus 3. So that would do something like that, for example, 1 and minus 3. Now it says determine the values of x for which the normal original graph, not this graph, they're talking about the original graph, is concave down. Check this out. Concave is all about the second derivative. Okay, the second derivative. And when the second derivative is equal to 0, we call that the inflection point. When the second derivative is greater than 0, we call that concave up, because bigger than 0 means positive, positive, positive people are happy, and concave up the graph looks like this, it's smiling, okay? Then we've learnt about when the second derivative is smaller than 0, that means concave down. People who are down are sad, unhappy, and so they look like that. Now, don't worry too much about the shapes. The shapes aren't really important in this question. What's important to realize is that what I've taught you before is that when you have the original graph, let's say it's equal to something, what is the first derivative? Like, what does the first derivative actually stand for? Gradient, right? It's the gradient. So if you take the second derivative, we know that that's all about concavity. But another thing that I want to mention is that if the first derivative is the gradient of this graph, then the second derivative will just be the gradient of that graph. So this one will be the gradient of that one. So if the second derivative then is the gradient of this graph, then you can see what the gradient is at any moment. Over here, we can see the graph is going down, so the gradient is negative. Gradient is negative. And then over here, we can see the graph is going up, so there we can say that the gradient is positive. But so this is this part here, this yellow part over here. Oh no, that's not good. Okay, so we had something like that. Sorry about that. So this yellow part is the gradient, and it's the gradient of this graph, which we said is the second derivative. Okay, so here we can say that the second derivative is negative because the gradient is negative. So here we can say that the second derivative is smaller than 0, meaning it's negative. And here we can say that the second derivative is positive because the gradient is positive. So they said, where is the graph concave down? And we said concave down is where the second derivative is negative. And so that's going to be all of this. And so it's going to be where x is smaller than 1. If you want to use interval notation, you could say x is an element from negative infinity up to 1. For this question, there's quite a lot that we're going to do. So I'm going to break the question, or these are all the questions we're going to do, but I'm going to break them up onto smaller parts, okay, just so we can fit everything in. But these are all the questions if you want to try them all by yourself. Okay, so they give us a cubic graph, and the first question for only 1 mark says, what is the y-intercept? So to find a y-intercept, you just make x equal to 0. So you'll just make x equal to 0 for all of this, and you're going to end up with negative 10. So the y is equal to negative 10 will be your answer. They're not asking for coordinates, so we don't have to say 0 minus 10. They just want to know what the y-intercept is. The next question says, show that the number 2 is a root of the equation. Okay, so when something is a root, it just means it is one of the answers. So pretty much, they just want to say, is the x value, if you plug in the x value of 2, will it give you, will it make this equation true? So they want f of x to be equal to 0. Okay, now you don't have to go solve it. They want to know, is x equal to 2? Is it one of the roots? So we're going to go plug in x as 2. Let's go plug in x as 2. So we can say right hand side. And we're just going to go plug in x as 2. So that would be 2 to the power of 3 plus 4, 2 squared minus 7 times 2 minus 10. And if we had to work that all out, you end up with 0. And so if you let x equal to 2, then this side does equal to 0. So this equation will be true. And so we've just showed that, therefore, 2 is a root. So that means 2 is one of the x-intercepts. 2 is one of the x, because 2 is one of the answers when this equation is equal to 0. And when you make an equation equal to 0, that's when you're finding your x-intercepts. Now they're saying hence factorize. So what are they actually doing here? We've gone over this before. Whenever you have an equation like this, a cubic, and you want to try draw that cubic, let's say for example it looks like that, one of the steps that we need to do is to find the 3 x-intercepts. And to do that, it's quite a lengthy process, remember. We have to first go guess the first answer, and you keep plugging in values until what happens? Until you end up with a 0. But this question over here is the one that gave us the suggestion. It's the one that gave us the clue. So we don't have to do that step anymore. So normally when you did do that step, you would go plug in values into the x, and you would keep plugging them in until you got a 0. So we found what one of the answers is. It's a 2. So then when you plug it into the bracket, can you remember how to do that? You're not going to say x plus 2, you're going to say x minus 2. Yeah? And then what are we going to have left over here? Well, this is that part where we have a trinomial, but we don't know what the numbers are. Okay? Because what we have is we originally had f of x equals to x3 plus 4x squared minus 7x minus 10. And now we're just trying to factorize this as far as possible. So we can say here that f of x is equal to that. So this is that part where you can either choose to use the x squares, or you can choose to use the x's. This is also the place where some learners use synthetic division, or some learners call it the block method. This is where you could also do that. So I'm going to choose this one over here. Okay, so that means that I want all of the x squares to be equal to 4. Because remember, this is supposed to be equal to this over here. Okay, so what I'm going to do is I said that I want all the 4s to be equal to x squared. So where would I get x squares over here if I had to multiply these two brackets together? Where would you get x squared? Well, you would get an x squared whenever you multiply these two together. So that's b x squared. And then it would also be when you multiply these two together. So that's minus 2a x squared. Oh, but we can also fill in the values of a. Because I know that when I multiply these two together, that'll give you x cubed. And the x cubed is supposed to be equal to what number in the front? A 1. So that means a is a 1. So we can fill in a as a 1, so you don't actually have to do anything, so you can just do that. Now, I can also work out the value of c, because I know that the constant is minus 10. And so if I had to multiply this one and this one together, that'll give me a constant. There will be no x. And so I know then that this value must be a 5, because 5 multiplied with minus 2 gives us that. So this will be a 5. Okay, so now so now we can go solve this equation. We can cancel all of the x squares now. And so we end up with 4 equals to b minus 2. And so b would be equal to 6. So now I can say that f of x is equal to x minus 2. And then the a value, I have made videos on this technique before, okay? Plus 5. Now I can go factorize this one. And that would factorize as x plus 5 and x plus 1. So it says, hence factorize completely. Well, there we've done it. They don't want us to solve, they just want us to factorize it, and so we factorized it. This question says, if it is further given that the turning points are there and there, draw a sketch graph labeling all intercepts and turning points. Very easy. That's why it's only worth 3 marks, because we already know the y-intercept is at minus 10. So we can just say 0 and minus 10. Remember that these graphs don't have to be according to scale. Okay, then the turning points is at 0, 7 and minus 12,6. So that would be there, somewhere there. Okay, so I'm going to quickly just say here 0 and minus 10, and then this would be 0.7 and minus 12.6. And then the other turning point is at negative 3.4 and 20.8, which would be somewhere over here. Negative 3.4 and 20.8. And then the only other things that we would need now would be intercepts and turning points. Okay, so we've got the turning points. Now we need intercepts. So we've already got the y-intercept. So you would get your x-intercepts from this equation. To find x-intercepts, you make y equal to 0. So I'm going to take that equation, I'm going to make y equal to 0, and so we're going to end up with x take away 2, x add 5, x plus 1, and then you would just say that x minus 2 equals to 0, or x plus 5 equals to 0, or x plus 1 equals to 0. And so therefore x would be 2, which we already knew from there. X would be minus 5, or x would be minus 1. So those are your three x-intercepts. So minus 1 would be somewhere around there. I'll fill in the coordinates now. Minus 5 would be there, and then 2 would be there. Okay, so 2 and 0. Let's just draw this thing. So it's going to go something like that. Turning point, y-intercept, turning point. Okay, so we can fill in our intercepts, minus 5 and 0, and then minus 1 and 0, and then there we go. We don't need to find the inflection point. They never asked for that, and it's only for 3 marks. Okay, now remember, there's still more to this question. So now it says, use your graph to determine the values for which this. Okay, now remember what this means. It's the first derivative, but what if I told you what the first derivative actually means in easy to understand kind of language? It's just the gradient. So they are asking, where is the gradient smaller than 0? So where is the gradient negative? Well, remember, when the graph goes down like that, that's negative. When it goes up like that, that's positive. So where would the gradient be going down? Or where's the graph going down? Well, that would be all of this up to there. Okay, remember, as you move from left to right, where is the graph going downhill? Because some learners tell me, yeah, but sir, this one's also going downhill if you're going this way. But the rule is you have to go that way. Okay, so to write the answer, we could say that x is, I'll show you using interval notation and set border notation. You could say that x is bigger than minus 3.4, which is this part, but then it's smaller than this turning point, which is at 0.7. If you wanted to use interval notation, you could say x is an element from negative 3.4 up to 0.7. Now, this question says, where is the gradient of a tangent a minimum? I've seen them ask this question a few times now. Now, when they're talking about a minimum gradient, so if we look at a cubic graph, okay, I'll show you just 2 basic cubic graphs. You get one that does that, and then you could also get one that does that. So on this type of cubic graph, the minimum tangent, so remember, a tangent would be a line like that, or that, or that, okay? Touches the graph at one place like that. So where would the minimum be? Well, the minimum is always going to be at the inflection point, which is at this point over here. If you had to draw a tangent there, the gradient would be very negative, which we call that a minimum, because it'll be like negative 10, for example, which is a very small number. Now, on a graph like this, there would also be a tangent at the inflection point. Well, the maximum gradient would be at the inflection point over there. Here it would be a maximum because here the gradient is positive and it would maybe be like a positive 10. So a graph like this can only have, well, it can have a minimum tangent, but it won't have a maximum tangent because this graph is going down by the inflection point. So the point I'm trying to make is that the tangent minimum or tangent maximum is always at the inflection point. If it's a graph like this, it has a minimum. If it's a graph like this, it has a maximum gradient for the tangent. So the minimum tangent, or the gradient of the tangent where it will be a minimum, would be at the inflection point. So we need to go find the inflection point. Now, to find the inflection point, we need the original equation, which was f of x equals x cubed plus 4x squared minus 7x minus 10. So to find the inflection point, we need the second derivative. So we first have to get the first derivative, 3x squared plus 8x minus 7. Then the second derivative would be 6x plus 8. Now to find the inflection point, you make your second derivative equal to 0. So if we had to get the x by itself, I'll take the minus 8 over to the left, and then I'll divide everything by 6, and so x would end up being minus 8 over 6, but if you simplify that, that is negative 4 over 3. And so it says, what is the gradient of the tangent where it will be a minimum? Well, we know that the x value is going to be negative 4 over 3. So we know that the x value will be negative 4 over 3, which is somewhere over here. And that's all that they want. That would be the answer, because they said use your graph to determine the value of x where the gradient of the tangent will be a minimum. And we just found out that that would be over there. Now this next question for 3 marks looks horrible. I do understand that. But once again, if you are a student that gets 30%, 40%, 50%, 60%, remember that you don't have to attempt every single question. You can attempt this question, but remember that it's only worth 3 marks. So if you know that a typical exam is 180 minutes, and it's typically 150 marks, if you go and divide those two numbers, it means that you have 1.2 minutes per mark. So if you then multiply 1.2 by 3, you get 3.6 minutes that you should spend on this one. Now, what does 3.6 minutes even mean? Well, it's 3 minutes, and then 0.6 means 36 seconds. So you don't want to take any longer than that for this question. Otherwise, it's wasting your time. Okay, so you can definitely try it, but don't, spend like 7 minutes on it, for example. It's just going to make the rest of your exam more stressful. Okay, so they want to know where is this, which is your first derivative, which is your gradient, and then this, which is your second derivative, which is your concavity, which tells you what the graph looks like. They want to know where is that smaller than or equal to 0. Okay, so the way that these questions work is the following. Well, I first need to talk about something. The first derivative. Remember that the first derivative stands for gradient. So when a graph does something like that, for example, in all of these areas here, you can see that the graph is going up. So there we could say that the gradient is positive, bigger than 0. And then on these areas here in the middle, we can see it's going down over there. And so in those types of places, you would say that the first derivative is negative. Okay? Now, when you talk about second derivative, with second derivative, it's all about smiley faces and sad faces. So when you have an area that is like this, can you see that that's like a sad person? Can you see the sad face? That is where your second derivative is smaller than 0. It's negative. And then areas like this where there is a smiley face or a happy face, that is where your second derivative is positive. So areas like this are sad. Areas like this are happy. The place where they switch from sad to happy or happy to sad is called the inflection point, which is usually somewhere like there. Okay? So you need to understand that those two things to be able to easily do this next question. Okay. So I hope you've made some notes there if you didn't know that, because I need to clear all of that up now just for some space. So the way it works is the following. If we do a table of f of x and that, now if your first derivative is positive and this one is positive, then if you had to multiply these two expressions, that would also be a positive. Okay? If this one is positive, but this one is negative, then you would end up with a negative. If this one's negative and this one's positive, you would end up with a negative. And if this one's negative and this one's negative, then two negatives once again make a positive. So they want to know, where is this ugly expression smaller than or equal to 0? So smaller than 0 means negative. So they want the negative answers. They want this whole thing to be negative. So they want this whole thing to be negative. So that would only be this one and this one, because here we can see it's negative. So we're not going to look at this one, and we're not going to look, okay, it doesn't really help if I use the same color. We're not going to look at this situation, and we're not going to look at this situation. So let's actually just go take those out. Okay. So we need to go and find places on the graph where, let's start with this one. Let's call this number 1 and let's call this number 2. Let's divide them up. So let's go look at number 1. So we're going to go find places where the gradient of the graph is positive at the same, okay, so let's go find that first. The gradient of the graph is positive. So that would be here because it's going up, and that would be over here because it's going up. Now, in that situation where we've just found the gradient is positive, are there any places where the graph is a sad face? Remember, the second derivative is the happy and the sad, and when it's negative, it's a sad face, which is like this. So what we can see in this area over here is that that's a smiley face area. Can you see the smiley face that the graph is making? You can see if I had to put two little eyes over here, you can see the graph is smiling. But if you look in this area over here, this is more of a sad face type of area. You can see if I had to put smiley faces, if I had to put eyes, that's a sad area. So we're looking for places where the gradient is positive, which is the yellow parts on the graph, and it's a sad face. So that would be this area over here. So the overlap would be this part here, because in this part here, it's a sad face kind of area, and the gradient is positive, and that's what we wanted for this first part. So for that first part over there, we could say x must be smaller than this number, which is the negative 3.4. And we can include the negative 3.4 because they included it as well. Okay. If you wanted to use interval notation, you could say x is an element from negative infinity up to negative 3.4 with the square bracket. Now we're going to say or, because now we need to go and see if we could also maybe get some answers from our second possibility. So in our second possibility now, the gradient must be negative. So here the gradient is negative from turning point to turning point. And they want it to be a smiley face area. Well, this area over here is a sad face. This area over here is a happy face. The place where that changes is your inflection point, which is usually over there. So what we could say is that the gradient is negative, and we're looking for a smiley face because it means positive. That would then be this area over here, because there the graph has a negative gradient and it's a smiley face type of area where the second derivative is positive. And so remember what that second derivative value was. We worked it out when we were busy with this one. We got negative 4 over 3. Okay, so we could say then that it's from negative 4 over 3 up to the turning point of 0.7. So we could say x is bigger than or equal to negative 4 over 3, but smaller than or equal to 0.7. If you wanted to use interval notation, you would say negative 4 over 3 up to 0.7 with square brackets, because we are including them. A wire which is 12 meters long is cut into two pieces. Okay, so we have a 12 meter long wire. Now it's cut into two pieces. Now don't automatically say 6 meters and 6 meters. What you rather want to do is actually make it not like that. Make it so it looks like that, for example. Now one part is bent to make an equilateral triangle. Okay, so let's say this part here is going to make an equilateral triangle, and the other part is going to be bent into a square. Okay, so let's say that this part is going to be the square. So it says that a side of the triangle has a length of 2x. So if this length is 2x, then this would also be 2x, and this would be 2x, because it's a equilateral triangle where all three sides are the same. That would then mean that this whole length would have to be 6x, because this whole piece of wire, they took it and they bent it to make this. Okay, and 2x plus 2x plus 2x is 6x. So if this whole length is 12 and this length is 6x, then this would have to be 12 take away 6x. Now, the first question says, write down the length of the sides of the square. Well, this entire length is 12 minus 6x, and that has to be made into 4 sides of the square. So we are going to have to take 12 minus 6x and then divide that by 4. And that's going to end up giving you 12 divided by 4 is 3, and then 6 divided by 4 is 1.5. So 1.5 x. Okay, so we've got that as 3 take away 1.5x. This one says, if this square is now used as the base of a rectangular prism. Okay, so they're just going to take this square, which I'll draw over here, and they're just going to make it into a rectangular prism. So for example, oh no, the base. Okay, so this will be like the ground, so you could imagine it like that, and then they're going to draw a rectangular prism. So they're going to use the square as the base, the bottom, like that, for example. Okay, you could also picture it. Yeah, I mean, that's what they're going to do. So it says, if the square is now used as the base of a rectangular prism with a height of 4x meters, okay, so we've got this square now. I'm just going to do it at an angle, okay? I'm drawing it at an angle. Just trying to do a bit of 3D over here, something like that. The guys who do technical drawing, they're like, bro, what's this guy doing? Something like that. Okay, so we know that each of these lengths is 3 take away 1.5x. Okay, all the way around. Each one is going to be 3 minus 1.5x. Now, they said that the height of this prism is going to be 4x. Now, it says determine the maximum, hello calculus, volume. Okay, easy. So we've done a lot of calculus optimization kind of questions. So the first thing we need to go do is find a formula for the thing that they want us to maximize, and that in this case is volume. So we know that volume is area of the base multiplied by the height. So the area of the base, well, the base is a square. To find the area of a square, you multiply two sides together. So that's going to be 3 take away 1.5x multiplied by another 3 minus 1.5x. That's your area of your base, and then you're going to multiply that by your height. Let's rather do it like that, which in this case is 4x. Okay, I'm going to put the 4x in the front. So it's going to end up being 4x, and then 3 take away 1.5x, 3 take away 1.5x. Now, the next thing we've learned to do is we need to go simplify this as nice, as best as possible, make it look nice and simplified, and then we can start using calculus and the first derivative and all of that good stuff. So I'm going to work back up here now. So let's get rid of all of this. And so we could say then that the volume is going to be 4x. I'm then going to multiply these two brackets together, but leave the answer in a bracket. So 9, because 3 multiplied by 3. And then take away 3 multiplied by 1.5, I think is 4.5. Yeah, so minus 4. You could also use fractions like 9 over 2. And then this one's also going to be minus 4.5x. And then we're going to multiply these two together, which would become a positive 2.25 x squared. The next step, I'm going to go multiply the 4x into this bracket, so it's going to become 36x. 4 multiplied by 4.5 is 18x squared, and then another 18x squared, and then 4 multiplied by 2.25 is going to be 9x cubed. So here we have an expression for the volume, but to find a maximum we have to take the first derivative. So there's multiple ways you can do this. You could say here that v of x is equal to 36x minus 18x squared minus 18x squared. Oh, let's simplify, sorry. Let's make this minus 18 and minus 18, let's make it minus 36. Let's make it minus 36x squared. Okay, so we could go write it as like v of x, which is then using the f of x notation. So then when you take the first derivative, you could do it like this. Okay, that's the same as having f of x, right? The other way is you could go write it as, you could just say that v is equal to that. And then if you take the derivative, you could say the derivative of the volume with respect to x. That's the same as using like dy over dx. And then you could go take the first derivative. So whichever one you're comfortable with, okay? Now, if we go take the first derivative of this, you just get 36. If you take the first derivative of this, you're going to multiply the 2 and the 36 together to become negative 72, and then x to the power of 1. But you don't need to write the 1, so I'm just going to leave that out. And then 3 multiplied by 9 becomes 27, and then 3 take away 1 becomes a 2. Now to find minimums and maximums, you would make your first derivative equal to 0. So we would do that. And now it's just a quadratic equation. I'm just going to use the quadratic formula. X equals minus b plus minus square root b squared minus 4ac over 2a. Now, just show them what you plug in. So x equals, so b, be careful. This is a, this is b, and this is c. A always has x squared, b always has the x, and then c is always the other one. So b is going to be negative 72. So it's going to be negative 72, because there already is a negative there. Then it's plus minus. Then it's b is negative 72 squared minus 4. A is 27. I'm running out of space here, aren't I? And so let's just try it here. Negative 72 plus minus square root of negative 72. I mean the square of 72 minus 4. Now a is 27. C is 36. And then over 2 times a, which is 27. Okay, now you can just go use your calculator to get your two answers. And so we get x is 2 or x is 2 over 3. Now, you've got to be careful. We've just made the first derivative equal to 0 because that is how we find minimums and maximums. So one of these answers might be a minimum volume while the other one might be a maximum volume. So we don't know. So we need to go plug both of these now and see what volume they produce. So we can plug each one back into our original volume equation. So you could do it to this one, or this one. Why? They all volume. It doesn't really matter. All three of these are exactly the same. Some of them are just more simplified than the others. So I like this one. Okay, you're not going to go plug it back into this equation. You're plugging it to find the volume. So I'm just going to get rid of this. So if x is 2, so if x is 2, let's see what volume we get. Okay, if you go plug that all in, you get 0 for the volume. Okay, so we don't want that. That's not like great. That's probably the minimum volume. If we then go plug in 2 over 3 instead, we end up with a volume of 10.67 meters. And so for this one, you would say no solution for the x equals to 2, because that would actually be a minimum volume, but they said determine the maximum volume. A group of people participated in a trial to test a new headache pill. 50% received the headache pill, 50% received a sugar pill. 2/5 of the group receiving the headache pill were not cured. 3/10 of the group receiving the sugar pill were cured. First question, represent the information on a tree diagram. Okay, so when you do a tree diagram, you just need to look for categories. So here's our first category, okay? So what I'm going to do is I'm going to make a little dot, and I'm going to draw 2 lines. This one will be headache pill. These are people who received the headache pill. And then these are the people who received a sugar pill. Now, the next category is the cured and not cured. So we're going to put 2 lines from each one. So this will be cured, and this will be not cured. Well, let's just say not. And then this will be cured, and this will be not. So for example, if I go this way, that would be people who took a sugar pill and they were cured. If, for example, I go this way, this would be all the people who took a headache pill and they were cured, for example. So we know that it was a 50% sugar, 50% headache. So I'm going to say 1 over 2. Let's draw that a bit nicer. 1 over 2 and 1 over 2. Okay? Now, 2/5 of the group who received the headache pill were not cured. So you see, headache, not cured. So headache, not cured is this pathway here. So they're saying that this part over here would be 2 over 5. Now, you see this branch and this branch, they are 1 unit. Whenever you have 1 unit, it always adds up to 1. So this would be 3 out of 5. Okay? Just like this branch and this branch is also 1 unit. And so if you add these two together, it will always add up to 1. Okay, now they tell us that 3/10 of the group receiving the sugar pill were cured. So that's going to be sugar and cured. So sugar and cured. So this branch is going to be 3 over 10. So we're going to put 3 over 10 for this one. 3 over 10. That means this part here would have to be 7 over 10. 7 over 10, because 3 over 10 and 7 over 10 is 1. Right, so now we have all the different branches that we need. So we did 10.1.1. Now this question says, determine the probability that a person chosen at random will not be cured. So there's two ways that a person cannot be cured. They could take a headache pill, but maybe it doesn't work, so they're not cured. Or maybe they take a sugar pill, and that doesn't work. Well, sugar pills don't really cure headaches, and then that would also not be cured. So whenever this happens, to work out the total of this branch, you will multiply the two numbers. So let's quickly do that. 1 over 2 multiplied by 2 over 5. You see I multiplied this number and this number together, and that'll give you 1 over 5 after you simplify. Then the green one is going to be 1 over 2 multiplied by 7 over 10, which would give us 7 over 20. Okay? Then if you have, what you then do with these two answers is you add them together. So 1 over 5 plus 7 over 20, and that'll give 0.55 or 11 over 20. Three events A, B, and C are considered. They give us A, they give us B, and they give us A or B. Okay, now they say, are the events A and B mutually exclusive? Well, let me show you what that means. If you have two circles, you know, like on a Venn diagram, if the two circles do not overlap, that is called mutually. If your circles do overlap, then we say that this is not mutually exclusive. So when you have two circles that are not overlapping in the middle, we call that mutually exclusive. So if this is A and this is B, then can you see that there's nothing in the middle that overlaps them? So the A and B must be equal to 0. That is what mutually exclusive actually is. It's when your probability of the two events so A and B, not or, and, must be equal to 0. So what we will do, because this is some really good information, whenever they give you a question with all of this information, there is a formula that we have in probability, which is actually on the formula sheet. And so it's this formula over here, guys. So don't forget about this one. So they told us what A or B is. It's 13 over 20. So we can just fill that into the formula. The probability of A is 2 over 5. The probability of B is 1 over 4. And then the unknown is this. And we're going to go calculate that. And so if I take this over to the other side, it's going to become a positive. Sorry, let's say rather and. And so we're going to have 2 over 5 plus 1 over 4 take away 13 over 20. And if we calculate this, we get 0. And so what I told you earlier was that when things are mutually exclusive, it means that there's no overlap. So the A and B must be 0. So we've done our calculations, and then we can say, yes, they are mutually exclusive. Why? Because the A and B part is 0. So if you had to draw out the circles, they would look like that. They would not overlap each other at all. Because remember that when they overlap, that part in the middle, that's the and. And if the and is 0, well then the circles have to be apart. All right. So remember that now in case we have to use that later on. The next one. Determine the probability of only C if it is further given that this, and all of this nonsense. Okay, let's have a look and see what we can do. Right, so I think we can try draw the circles. There's definitely a B and C. That means that the B circle and the C circle do overlap. And then there's definitely a A and C, so the A circle overlaps with the C. But the A and the B circle, they don't overlap. So how are we going to draw this? It's going to be something like that, where it looks like a Mickey Mouse. Where this, Kevin, you still watch Mickey Mouse? Guys, don't judge me, okay? I'm getting there. Hannah Montana. No, I'm joking. I don't watch that stuff, guys. I used to when I was a kid. Okay, so A, B, and C. So you see how the A circle and the B circle, by the way, I've been teaching for so long, I've never seen a question like this. Quite interesting. So the A circle and the B circle don't overlap. You see that. But the AC circle does overlap, and the BC circle does overlap, because they told us that there is an A and a C, and then they also told us that the A and the C is double the B and the C. Don't worry, we'll get to this in detail, but B and C and A and C do overlap. But A and B don't overlap with each other. Because normally, if everything overlaps, it would look like this. Yeah? Okay, so let's try fill in what we can. So none of these numbers, by the way, can be put on the diagram. You can't say that A is 2 over 5 and then you go put 2 over 5 over there. Nope. When they say that A is 2 over 5, it means the entire circle of A is 2 over 5. But we don't know how much is this part and we don't know how much is in that part. So we can't do anything with these numbers. The next thing we know is that A and C, so that's where A and C overlaps, that's there. That's 2 over 5, so we could fill that in. 2, why do they have to make these ugly fractions? Okay, so that would be 2 over 5, so A, B, and C. Now they tell us that the probability of A and C is equal to 2 times the probability of B and C. So mathematically that means that the probability of A and C is equal to double the probability of B and C. So then B and C is over here, would be half of that number, which would then be 1 over 5. The next thing is that probability of, okay, the probability of A or C. Now A or C is, okay, no, that's not going to help us just yet. Yeah, that won't help us just yet. But A or C is this, and this. So it's all of the A and all of the C. It's all of those combined. All of those combined must add up to 7 over 10. A and C, we've already filled that in. What else could we fill in here? Okay, A or B is 13. Oh, here we go. Ooh, hello. The whole of A is 2 over 5. The whole of A is 2 over 5. But this part here is already 2 over 5, so this part must be 0. And then the whole of B must be 1 over 4. So that whole part there must be 1 over 4. So if this is already 1 over 5, then to work out this part, we could say 1 over 4 take away 1 over 5. And that'll give us 1 over 20. All right, we're getting somewhere. And then A or C. So when they say or, it means all of the parts. So it's this, and this. All of that must add up to 7 over 10. So if you wanted to then work out this part, you would say 7 over 10 minus 1 over 5 minus 2 over 5. You could say minus 0 if you want. And that'll give us 1 over 10. There we go. So now we have everything shown on a Venn diagram. And so their question now says, determine the probability of only C. Only C is this part over here. So that would be 1 out of 10. All right, I went and looked on the memo. They just drew theirs like this. I'm being silly. We could have just done it like that. A, C, and B. But it doesn't matter. I just wanted to use Mickey Mouse. Okay, I got some trauma from Disney. Okay, so this one says, determine the probability that events A, B, or C do not take place. Oh, okay. What they mean is, if you had to go add all of these together, so if you had to go add the 2 over 5 plus the 1 out of 10 plus the 1 out of 5 plus the 1 out of 20, what does that add up to? You might say it should add up to 1, but that assumes that there's nothing on the very outside of the circles. So let's see. Oh, it adds up to 3 over 4. So we know that all probability adds up to 1. So A, B, or C, that's everything. Whenever they use the word or, it's everything. Like if they say A or C, that's all of that. If they say B or C, then that's everything in B and C. And then if they say A or B, then it's everything in A and everything in B, like that. Okay? So if they say A or B or C, they're talking about everything. Whoa, what happened to my circle? Was it like that? Yeah. Okay. So there might be something on the outside here. So what we just did is we went and we added up all of these numbers, and it did not add up to 1, it added up to 3 over 4. So you could then say 1 take away 3 over 4, and that'll give you 1 over 4, and so that would be on the outside. So it says determine the probability that the events don't take place. So they're saying what is the probability that none of A, B, or C takes place? Well, that would be this number, which is 1 out of 4. 7 friends, 4 boys and 3 girls. Let's quickly draw them out. So we've got boy 1, boy 2, boy 3, boy 4. Oh no, let's not make sure, otherwise we're making it look like they all sit there. But we've got 4 boys and we've got 3 girls. Okay, they want to stand in a straight line next to each other, because that's what friends do, to take a photo. Oh, I guess that is what we friends do. Okay, so in how many ways can the 3 girls stand next to each other in their photo? Okay, so the girls want to be next to each other, but it does not mean, this is the thing you need to understand, it doesn't mean that the boys are going to all be next to each other. Kevin, what do you mean, bro? If the girls are next to each other, then the boys have to be. No, they don't. Check this out. You could have a boy here, and then you could have 3 girls, girl 1, girl 2, and girl 3. And then you could have boy 2, boy 3, and boy 4. No one said the boys all have to be next to each other. You could have boy 1, boy 2, then the girls. And so what we do is we just group the girls together. So let's make it random, like boy 2, boy 3, boy 4, girl 1, girl 2, and girl 3. So the way I've taught you to do this is I want you to look at how many groups can you see. Well, there's 1 group. There's 2 groups. Well, that's group 2. Group 3, or how many units can we see? There's 5 units. So I want you to say 5 factorial. Then, inside each unit, are there any that have more than 1 item? Yes, inside here, there are 3 items. So I want you to say 3 factorial, like that. Okay? Let me explain where this all comes from. The 5 factorial, this part over here, is telling us how many ways can we arrange these groups. You know, you could put boy 2, and then you could put boy 1, and then you could put the girls together, okay? And then you could have boy 4 and then boy 3. But you could do that in a whole bunch of other ways. That's what helps us with the 5 factorial. Once that has been done, these girls can arrange themselves in multiple ways. You could have girl 2, girl 1, and then girl 3. Or you could maybe have girl 3, then girl 2, then girl 1. That's where the 3 factorial comes from. All right. And so if we're to work this out, 720. So there are 720 different ways that you could do this, where the girls will still be next to each other. Okay, now moving on to the next question. It says, in the next photo, determine the probability that Selwyn, who is a boy, and Lindiwe, who is a girl, will not stand next to each other. So whenever they do a question where they have the words at least, or they say will not, what we do is we do the complete opposite. We say, okay, we know that all probability, because they're saying probability in this question, all probability adds up to 100%, or you could think of it as the fraction of 1. So what we are going to go and do is we're going to ignore that, and we're going to say, what is the chance, or what is the probability? What am I saying? Probability that Selwyn and Lindiwe will sit together. Let's make them sit together. Ooh la la. That used to make me so nervous when I was in primary school. I'd like just sit next to a girl, and then all the kids in the class would be like, nah, 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 sitting in a tree. Yeah, I used to go so red. Okay, anyways, so what we're going to do now is, okay, so we're just going to go take all the 7 people, but we're going to make these 2 1 unit. Ooh. So Selwyn and Lindiwe, they are a unit. So we will put a box around them, and then the rest would be the other 5 people. So there's still another 3 boys, boy 1, boy 2, and boy 3, and then there's still another 2 girls besides Lindiwe. So it's the same thing now. You're just going to go work out how many things could you get here. Well, how many units can you see? 1, 2, 3, 4, 5. No, wait, why is there 6 units now all of a sudden? Oh, because there were 3 goals earlier. 1, 2, 3 at 1 unit, 4, 5, 6. So you're going to say 6 factorial. But now within this unit, there's 2 people. Lindiwe might sit there, and then Selwyn will sit there. Or Selwyn will sit there, and Lindiwe will sit there. So they could also arrange themselves. So that's 2 factorial. So if you work that out, that is 1,440 ways. So therefore, there are 1,440 ways where Selwyn and Lindiwe will sit together. What we're now going to work out is how many ways can these people sit together if there are no restrictions at all. Well, then you've just got 7 people. So that's just going to be 7 factorial, isn't it? 1, 2, 3, 4, 5, 6, 7. Because there's 7 units or 7 things. And so you just say 7 factorial. So let's quickly say now Lindiwe and Selwyn. Could be Selwyn. Lindiwe and Selwyn sit together. Oh, wait, but who's it? My name's Selwyn. Okay, Lindiwe and Selwyn sit together. That would be 1,440 ways. Then, what was I going to say? How many ways can the 7 people sit? And this is with no restriction. So anyone can sit next to anyone. Well, that's where we said 7 factorial. Did we even work that out? 7 factorial, which is 5,040. 7 factorial, which is 5,040. So now, how many ways can Selwyn and Lindiwe not sit next to each other? Well, if you should just realize that you could simply minus these 2 values from each other, right? So we could say Selwyn and Lindiwe not sitting together. That would be 5,040 minus 1,440, and that would be 3,600. So they said, what is the probability? So probability is always the answer that the thing we're looking for, divided by the total, which is 5040, and that's 5/7. So there is a 5 out of 7 chance that they will not stand next to each other.